Hello, Sushant. Shreyas. Shreyas is there here? Shreyas Kumbar,
yes,
are you there?
yes, sir. Yes, sir. Yes, yes, sir.
Mine is Bhupesh.
Yes, sir.
Shubham. Only 2 people are there. वो मैडम लोग 2 आया था कहाँ गए? Ladies they used to come ना?
पता नहीं सर, वो शायद ऑनलाइन
Yeah. About Hive, about Scoop, about HDFS, do you have any questions? And there are some exercises which are there. I left. I know that what I left. Okay, that's not part of your syllabus actually. वो syllabus में तो नहीं. मैं आपको बोला था मैं. I will tell you. No? It seems either you have gone through, fully understood 100%. Otherwise, you have not at all gone through. No question, no study, no doubts. More study, more confused. No study, no confused. What can I understand? Whether it's a more study, more confused or more clear? नहीं कैसा होता है, we will complete and go, that's all. But ultimately you utilize me maximum. That's what मेरा question. अगर आप लोग ऐसा आना चाहिए, आने के वक्त डॉक्टर देसाई को ये क्वेश्चन है 1 2 3 मैं 100 क्लैरिफाई. ठीक है, हम 2 दिन अवेलेबल है ना वीकली. उस वक्त तक वीकली आप लोग ऐसा प्रिपेयर करना पड़ेगा. ये क्वेश्चन है क्या क्या पूछने का, ये डाउट्स है मेरा, ये लेट अस क्लैरिफाई व्हेन इन द क्लास. Okay. See now, today we'll start one more different topic totally. That is Spark. Okay, I think since you people might have heard from many instructors, Spark is very important. Today, it is there in the market. Hive is also there as part of market. So before we get into Hive, yes, we have anyhow, you should know big data and all. MapReduce, big data, Scoop, okay. And Pig is not part of yours, this one. And Hive, anyhow, we know that which is used for designing data warehouse infrastructure on top of Hadoop. Now, as you know that data is coming continuously and day by day, data started coming more and more. When the data started coming continuously, we should be able to process quickly. Whatever that we had, MapReduce, Pig, Hive, we were able to process data, we were able to analyze data. They were all used for a batch processing. Okay. They were all used for a batch processing. So obviously it is to take a time to process the data. It is to take a time to analyze the data. But you know that today the data is coming continuously. So the processing data should be done very quickly. Otherwise, some data, suppose if you are taking a data from the credit card transactions, and if someone else stolen your credit card and do some transactions, and if I come to know later, it's of no use. Okay, immediately I should be able to know that, yes, this is actually a fraud which is taking place. So now when they started about processing quickly, okay, obviously we have to come up with the new technologies. Okay, new tools and all. If you go to MapReduce, okay, what was the disadvantage of MapReduce you found? Oh, what did you understand?
It will take more time to process the data.
Okay, it will take more time to process the data. Okay.
And it will first divided all the text into characters.
Second one is it's a huge code I have to write. 100 lines code I have to write for performing a task. If you believe that MapReduce actually how it works, okay. See, it's a disk oriented actually. So we have a data at backend, and this is our cluster. Okay, when you have this cluster, okay, so cluster is usually we know that we have a name node and we have a data nodes. And when I have a data node and name node, so these nodes, every node has a disk, every node has a memory, every node has a CPU. But our data is lying at bottom layer. Okay, data is lying at a bottom layer somewhere else. Now, when I perform some task, okay, when I perform a task, obviously what I do that I write usually either a MapReduce program or maybe a pig or hive program. So I write it like a hive, you know, that select star from something else. So your data is already here, and now I want to pull the data. I told you that every node has a disk, every node has a memory, every node has a CPU. Okay, this is what I call it as a local disk. So local, I mean, locally the data can be stored over here. When I submit MapReduce job, okay, which will pull data from this disk, okay, it will bring data over here. Okay, first what it does, it brings data into different nodes. Data get distributed over here. When the data get distributed here, okay, that MapReduce, first of all, a mapper job, mapper class, reads data from this disk. Okay, bring into main memory. Okay, bring into main memory. And I told you that mapper generates intermediate results. Okay, that intermediate results are written back into a disk. You read a source here, you have a part of data, here also you have part of data, here also you have part of data. Okay, when you submit MapReduce job, okay, the job will be there running on this node, running also on this node, running also on this node. Okay, parallelly, it is processing on all nodes, and your data is distributed partially here. Okay, not full data. Suppose if you have 100 records or 1,000 records you have here, so maybe 60 records are here, maybe another 50 records are here, okay, or 500 records are here, around 400 records are here, maybe 300 records are here, like this. It will get distributes in all nodes randomly. Okay, now this particular job reads data from the disk. That's what a local disk, because data is available locally. In the beginning only data get distributed. So when it reads data, okay, now it reads data from the disk from here. Then it brings into main memory. It brings into main memory. Mapper, anyway, mapper is performing the task. Mapper reads data and bring into main memory, and it generates some intermediate results are written back into a disk here only. Okay, it written back into a disk. Then sort and shuffle, these are two tasks which will get performed. Again, they bring data back into main memory. It has to sort the data. When you are sorting the data, some data go here, some data go here, some data come from here, some data comes from here. Like this, it will swap across all nodes and all partitions. Okay. So that result finally sort and shuffle. Okay. Then this one is there. Reducer will get work. That output is also being stored here. Then reducer will start. Reducer again, it reads whatever the output is here. Intermediate results are there. From there, it brings data. Perform a task, okay, and combine this all result here and send it through memory. Send it through the name node. So here, what I'm trying to say, when your data get distributed across all nodes first, in the form of partitions, that, and your mapper performs on the data which is stored in the local disk. Bring them into main memory. Okay, perform the task, push intermediate results back into a disk. Again, sort and shuffle reads the data from the disk. Perform the task and return, final result is being returned to this. Then your reducer comes into the picture. So reducer reads data from all nodes here. Okay, aggregate that result, and the aggregate results are being sent back to a user. So here, there are a lot of IO operations are here. A lot of IO operations are taking place. Okay, that is what the map reduce or pig or hive are considered as a disk oriented. Okay, disk oriented. That is disk oriented. Okay, so when you are reading data from disk and reading data from memory, a lot of difference is there. Reading data from memory is quickly it can read the data, but when I'm reading data from the disk, means I have to bring data and bring them into a main memory. Okay, so due to that, it takes MapReduce takes one is a lot of time, it's a disk oriented, and third one is very important is a lines of code we have to write using a procedural language. Using procedural language, we have to write a lot of lines of code. That is a disadvantages. They are the what a disadvantage of MapReduce. So then we gone for a new technology. That's what which is a in-memory technology. Not a disk oriented, in-memory technology. Anything you do, it writes on the disk only, memory only. Again, it reads data from the memory only. Okay, based on in-memory technology, I think there was a database also was introduced. You might have heard about SAP HANA. SAP HANA was the in-memory database. Okay, there's no disk. Okay, already it is mounted in the memory. From there only it will get processed. So same thing here. So this is Spark is also based on in-memory technology. You read data only once, bring them into main memory, perform all tasks in the main memory only. Then last output is written back into a disk, wherever you want. Only twice it read data from the disk, and lastly it writes into the. Otherwise, everything is what on in memory. So now when you come to a Hadoop part, okay, I think we know that in case of Hadoop, we know that already, right? So this is a core Hadoop, okay, and on top of that, we have a ecosystems, right? It's an ecosystem. So one more ecosystem, okay, the Spark is also one of the ecosystem of Apache. Okay, so we know that last week we have seen a here Scoop, okay, where we is importing and between import and export between RDBMS and Hadoop. Here we have a Hive also. We have seen architecture, how the architecture of Hive. Okay, here we have also seen. I think we have not seen it. A Pig is also one tool which is sitting on top of Hadoop. Okay, so but Pig and Hive are used for processing and analytical tools. Scoop is a data ingestion tools. Now in the similar line, there's a Spark also we can keep. Okay, Spark can also be kept if you tell you want to keep on top of Hadoop. Okay, Spark can be kept on top of Hadoop. Okay, so otherwise you can also keep a Spark independently. Only for computational purpose, you can keep a Spark. Okay, if you keep a Spark on top, if you install Spark on top of Hadoop, then it anyway, you know that Hadoop architecture. Okay, we have a name node, we have a data node and all. Okay, so the same architecture even that Spark follows. Okay, Spark follows the same architecture. Now, coming back to the Spark is in line with the Scoop, Hive, Pig. Spark is also which you can keep on top of Hadoop. Or I can keep Spark separately also. Independently also I can keep it. It's not necessary that I should keep on top of Hadoop. But Pig and Hive we can keep on top of Hadoop only. Without big data or without Hadoop, you cannot work. But Spark can work without a Hadoop also. Okay, so you can use directly, this can be your Spark cluster. You can build a separate cluster. Okay, you can build what? A separate cluster of Spark. I can build a separate here. We can build a separate Spark cluster also here. Okay, so it follows its architecture. I'll discuss about this architecture of Spark and all. So when you are using this, it can, this, whenever the data which is stored in this place can be input to this, can be input to a Spark. It can read data from a Hadoop also. Hadoop can become a source. Okay, once the data get processed here, I can write data into a database also. I can write data into a database also. Now, tell me that how did you import data from RDBMS? How did you export data in RDBMS in Hadoop? Using what? A scoop. Okay, it is between import and export. Okay, okay, with the RDBMS. With the RDBMS, any RDBMS you can take it. Right. Now, second, how did you pull data from web server? How did you pull? What was the tool you have used to read or import or ingest data from a web server in Hadoop? Which tool? Kafka is one. One more is a Flume. Okay, Flume is another tool to pull data from a web server. Okay, any streaming data can bring to this. Now, how did you do a machine learning on top of Hadoop? Any idea? I'm not talking about Spark. Forget about Spark. How did you? And did I tool any one tool? I told you can also do machine learning on top of that. That is Storm. Apache Storm is there. Okay, which is used for machine learning. Even based on that, Mahout is also one tool. Okay, these two tools are used for a machine learning. Okay, Apache Storm or Mahout. This is for used for a machine learning purpose. Here, Kafka and Flume can be used data from web server or almost near real time. Then RDBMS data, we know that already, this one. So how many tools we are using? So we are using Scoop, Kafka, Flume, Apache Storm. Okay, even if how did you process the data? You might have processed the data. How did you process data? We may be using a PIC. We may be using a MapReduce. Okay, we may use even Hive. One of them we can use to process data or to analyze data. This one, MapReduce and Hive, it is used for processing data and also it is used for analyzing data. How did you import data? I mean, yeah, it can be used. One of them can be used. So totally how many tools we are using? Scoop, Kafka, Flume, Apache, Pig, Hive. Okay, Scoop we are using. So they are all different tools we are using here. These all tools can be replaced with, okay, only one tool, that is what? Spark. Spark can do anything. Spark can read a data from RDBMS. Spark can also push data into RDBMS. Okay, Spark can data from RDBMS. Spark can also write data into RDBMS. Spark can also read data from web server, Twitter, any social media, which is coming in. That's called a Apache Spark streaming. We call it. Spark can also library called what a MLib. We can use that for performing a machine learning operations. Okay. In order to bring data from RDBMS into a Spark to process or analyze, there is a tool, there is an ecosystem of Spark called Spark SQL. Okay. So all part of Spark only. Okay, Spark SQL, which you can use to import and export data between RDBMS and Hadoop. Spark streaming can be used to bring data which is coming from any web server or real-time scenario. Third one is, if at all you want to perform machine learning operations, yes, you can, there is a Spark MLib. There is a Spark MLib. It is an ecosystem of Spark. It means that, so since we did multiple tools here, so these multiple tools can be replaced with a single tool, that is Spark. Now, this Spark is developed by a person called Zoharia. Zoharia is a person who developed Spark in 2009. Okay, then he donated. Actually, it started its project. This project has started in 2016 only. But 2009, when he reached certain benchmark, okay, then he made it as a version 1. And that he donated to Apache Foundation. You know that Apache Foundation is an open source. From there onwards, it's become Apache Spark. So many people have started contributing. Okay, because it's an open source, Cloudera, Hortonworks, Yahoo, Facebook, everyone started contributing to a Spark also. It started with the 1.0 version. Today it has a 3.6 version. Okay, 3.6 version Spark. So a lot of changes they have made. Lot of changes they have made. One thing you remember that in case of a software, whenever version gets changes, there are decimal number and also integer. Like for example, to 1.0 to 1.5, it means that your decimal number is changing. That means that there are some minor changes are there. Okay. If you 1.5 to directly, if you are moving to 2.0, it means there is a major changes have taken place. Okay, major changes have taken. If any small changes are there, they'll put after decimal point. Okay, if any major changes will take place, then they'll put the total integer will get changed. Like 1.0, 1.1, 1.2, 1.3. These are all the small changes are there in version 1. Suddenly 1.0 become a 2.0, there is some major changes have taken. Okay. Can you see it now? Okay. So now let's go to the whatever they have here. The first part, prerequisites. What is prerequisites for learning a Spark? Main is a big data. You should have understand about MapReduce, understand about Hive or Pig. Then you can come for this one. Now, if you look into batch processing and real time, can you give me an example of batch processing? One example of batch processing. Batch processing means bulk of data will process at one time, one at a time. What is it?
Python.
Python is a tool.
When we use machine.
Batch processing ka example. I'm not asking about a question about a tool and all. What is the example of batch processing? In which batch processing means where we process bulk of data at a time. कुछ example है क्या? नहीं, वो अलग. Just I'm giving OLTP का example क्या देता है आप लोग? What is the example of OLTP? Banking में क्या है? कौन सा transaction?
Daily report.
हाँ?
Daily report.
The best example ATM is an OLTP or reservation system. This is an example of OLTP. Now batch processing का example if I ask, okay, where I am processing data. Example is your payroll. Salary का. हर दिन तो मैं salary का process नहीं कर रहा है ना. Monthly एक बार transactions में देखता हूँ. How many people are absent, how many people are able leave, how many people are attended office and all. Accordingly, I will take entire data and process one time. That's called a batch processing. Means batch wise, I am processing the data. Okay. So in batch processing, say the difference here. Large group of data is processed in a single run. Only one time. I'm not daily. Are you processing your salary on daily basis? No, salary is processing, payroll is being processed once in a month. Right. But sales system, daily basis. Reservation, daily basis. That's not a batch processing. I'm not taking that, so kitna aaj sham tak kitna aayega reservation, let me process. I'm not doing that. That's called an OLT, online transaction. You are performing transactions online, continuous. Batch means I'm not doing online. I am processing once in a month, once in a week, once in a even year also sometime. That's called a batch processing. So when whatever data comes within that time, entire data I get processed. Okay. Jobs run without any manual intervention. I'm not running one job at a time. When I want to process a salary, because there's a payroll system, I will take data from the attendance, how many employees are there, how many leaves, how many days the officer attended, how many of them taken leave. Okay, suppose if you are gone beyond, suppose you are allowed 2 days leave in a month and you have taken 5 days. So automatically your working days is 20 minus supposed to be 2. Okay, you are making 5 absent. So obviously 3 days salary I have to cut. Okay, but that is what I'm whole month data I'm taking. Then I am processing. That's called what? This one. Job means only one time it will run. Job. Okay, the job run without any manual intervention. The entire data is pre-selected and fed using command line and script. Like suppose you may be having a job. Okay, you may be having a job. Suppose, for example, you might have written a big program in Python, where it reads data from employee and calculate their basic salary. Based on basic salary, you may be having certain allowances and all. You are calculating graduate salary, gross salary. Then you have some deductions. So gross salary minus deduction, it is become a net pay. That you have already a job. Okay, that job will is used The entire data is pre-selected and fed using command line or a script. Script, when I say command line, or I can run one by one, or I can write an entire script for this. It's used to execute a multiple operations and handle heavy data load or reporting and offline data workflow. It is normally batch processings are being used for a huge or heavy data. Like monthly, my process kar raha hai the data only one time, once in a month I'm processing. Obviously, I have a lot of data. अगर online है तो छोटा data रहता है ना online का. Okay. So example is a regular reports requiring decision making and all kind of a batch processing. When it comes to real time processing, real time. Okay. So now your flight ticket book कर रहा है. Okay, 10 ticket है, 10 seats are available. Train ticket you are booking, 10 seats are available. You book automatically one deducted. Online. Okay, data processing take place upon entry. Okay, the processing, suppose the moment, suppose if you, there is, you know that there is a, when you are booking a reservation, when you are performing a reservation in bus or train or flight, so you know that there are 5 seats are available. You book one. Okay, automatically they deduct 1 seat and make sure shows as a 4 seats are available. Right. So the moment you enter it, then it will perform the task. Transaction will get performed. It must execute on response time within strengthened constraints. Within few minutes, even few seconds, it should get processed. ऐसा नहीं आप ATM कार्ड स्वैप करो, जाओ बाहर चाय पी कर आओ, बाद में आपका अकाउंट नंबर पूछेगा. ऐसा नहीं ना. The moment you swap the card, it will ask you enter your password, enter your how much amount you want. Okay, it will not take its own time to process, and then you cannot wait. The moment you swap the card, it will ask your amount, how much amount you want, you give a PIN code. Then the moment you send it, immediately it gives you money. No response time. Easy. Immediately it will give it. Okay, that's what a kind of a real-time processing. It suppose you have a insufficient balance and you are trying to withdraw more. You have 10,000 rupees in balance, but you are trying to withdraw 10,001 rupee. Does it give you? No. Or even you try to withdraw 11,000 rupees, it doesn't give. Online it is checking immediately how much kitna balance hai, kitna aap withdraw kar raha hai. It's all online only. Okay, it must execute on response time within strengthened constraint. Use cases of fraud detection is one example. Online real time means fraud detection. Somebody is swapping your card, so ऐसा होना चाहिए आपका card somebody stolen and swap your card the moment I should able to understand. क्योंकि you have a card. Let us take you are a student. You know that you can spend monthly, say for example, 10,000 rupees using credit card. And suddenly if somebody, and you have a limit of 1 lakh rupees. If somebody has stolen your card, what he tried to do, he will not take only 10,000. Na? तो कितना चाहिए उतना उठा सकता है वो पैसा. अगर suddenly if 1 lakh rupees किया, swap किया, okay, it should alert you ना, because behavior get changes immediately. ये बंदा 10,000 खर्च करने वाला है, 1 लाख रुपए एकदम खर्च कर रहा है, तो बैंक वाला फोन आएगा, have you swapped your card? Did you observe it? Okay, have you swapped your transaction? Shall I approve it? अगर even if you give a check to any bank, अगर मैं 50 लाख का चेक किसको भी दिया, they will not pass unless until owner get confirmed. बैंक से फोन आएगा, आपका एक चेक आ गया मुझको, तो इसका 50 लाख का है, आपका है क्या, आप दिया क्या किसको, पूछेगा नहीं, क्योंकि कंफर्मेशन दैट्स अ मैनुअल है. बिफोर दे अप्रूव इट इन सिस्टम, दे हैव टू अप्रूव इट, राइट. व्हेन बिफोर अप्रूवल लेट दे कंफर्म इट विद द ओनर. रजिस्टर्ड मोबाइल नंबर से मोबाइल वो भी चोरी हो गया तो इट्स योर बैड लक. इफ समबडी टेल्स योर मोबाइल मुझको, अब मेरे पास भी है, योर क्रेडिट कार्ड भी मेरे पास है, मैं उठा सकता हूँ, हाँ मैं दिया था चेक बोल सकता हूँ. But still they have second check. Give me your date of birth or something, some secret numbers and all. Okay, because of they want to validate if it's too big transactions. Okay, so they are all what a do example of real time this one. Limitations of MapReduce we have seen first. One is unsuitable in real time processing. It is not, because it's a disk-oriented. Okay, it's a disk-oriented. Being a batch-oriented, it takes minutes to execute jobs depending upon amount of data and number of nodes in the cluster. Okay, that is a MapReduce is more suitable for a batch processing. Unsuitable for trivial operations. For operations like a filter, joins, you might need to rewrite the job. I think in MapReduce, I have shown you only one example, that is a word count. अगर आप just filter पे करना चाहता है तो एक बड़ा प्रोग्राम लिखना पड़ेगा. partition करना चाहता है तो बड़ा प्रोग्राम लिखना पड़ेगा. Whatever you want to do, you have to write a program. That's the biggest challenge in case of MapReduce. Unfit for large data network, because of it is not suitable for say this one real time. So your data should be available locally. That's what we do, we input data, then only we run a MapReduce job. MapReduce job will not run on go. Okay, first we input a data, then we process it, because data is available locally. It is not, MapReduce is not suitable for online. Okay, so unfit for large data on network, because large data network means when the data is coming continuously, this is not suitable. Unsuitable with the OLTP. Okay, unsuitable with the OLTP. Like OLTP means a real-time scenario. Like the moment I cannot use a MapReduce job for this reservation and all. You use the online processing. It's not suitable. Unfit for processing graphs. Okay, it's not, we were not used actually for processing a graphs and all, MapReduce. And unfit for iterative executions. Being a stateless execution, MapReduce doesn't fit with the use case like a K-means that need iterative executions. Like in आपको पता है machine learning में, I think you know that clustering, right? So clustering में आप K-means algorithm use कर रहे हैं. So K-means algorithm, then you are finding the first, pick up one element, then find out the distance between all elements, whichever minimum वो एक करो. Okay, then make a group, then pick up another random element, then find out which is nearest to that, make another group. So for that and all, this MapReduce is not suitable. That's not suitable. Hence, we go for always where I am going to process quickly. So that can be done with the help of Spark. Spark is a in-memory technology. Now, Spark, when I say a Spark, here, Spark is also an open source. Okay, Spark is also an open source today. Now it has a, suppose if you want to search Spark in Apache here, just type Apache here, Apache Spark. You'll find it, Apache Spark.apache.org. This is what it's a unified engine. Spark is one thing you remember, Pig or MapReduce or Spark or Hive. Okay, they are all just engines. When I say engine, they do not hold any data. Like your SQL. MySQL में SQL use कर रहा है, correct? MySQL में database में data store कर रहा है. But अब जब select किया, select, filter कुछ किया है ना वो engine कर रहा है. You are writing a query and submitting to SQL engine. Then SQL engine perform the task. Okay, but does SQL holds any data? Definitely no. SQL is one engine which is sitting on top of a, say, database. Same thing, whatever Pig, Hive, okay. So these are all kind of engines which are sitting on top of data, like a Hadoop. Okay, they do not hold any data. Spark do not hold any data. It only read data, process it, push. Pig, it reads data, process and push. Hive, already we have seen, it reads data from the disk, process it, and again it will push into somewhere else. They themselves do not hold any data. Okay, so it's a unified engine. Spark is what I said, it's a unified engine for large-scale data analytics. Large-scale data analytics. You can see here the definition. What is Spark? What is Apache Spark? Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on either single node or a set of nodes. That's called a cluster. When I say it's a multi-language engine for processing or analyzing data, means Spark alone can use different languages. Okay, when I say pig, which language it was used? Which is a scripting language for pig? Pig. MapReduce was Java. Pig. Hive, which language it is used as a scripting language? Hive, which language? Which is the scripting language for Hive? वैसा इंटरव्यू में क्वेश्चन दिया तो प्रॉब्लम है. Which is the scripting language you used for Hive? कब कैसा लिखा आप लोग? क्यूरी सभी. Which language you used? You have written query, na? Last week we have spent totally on Hive only, right? कैसा लिखा आप script? It's called an HQL. HQL stands for Hive query language. So Hive query language, which is based on SQL. Hive query language is based on SQL. They use a scripting language as a SQL or HQL. Same thing, Pig. They use a scripting language called a Pig Latin. Pig Latin was a scripting language for which we use for processing data, which we use for analyzing data. That's a scripting language. Is that scripting? Pig Latin is a data flow language. Pig Latin is a data flow language we use to process data. Anything you write in Pig, we use a Pig Latin. Anything we write in Hive, we use a SQL. Similarly, anything we want to write in Spark, we use a different languages. We may use a Python, we may use a R, we may use a SQL, we may use a Java, we may use a .NET. We may use even R also. Okay. We may use a different, that's what it's called a multi-language. When I say multi-language, you can use any interface language here for processing or analyzing data. Spark with Scala you can use, because Spark originally developed using a language called a Scala. Scala is a language like Hadoop is written in what? In which language Hadoop is written? Where? Java. Hadoop is developed in Java. Hadoop is written in Java language. Right, when Hadoop is written in Java language, similarly a Spark is written in Scala language. Scala means scalable language. Scala stands for a scalable language. Scala is a functional programming language. Okay, Scala is a functional programming language. Originally, Spark is written in that language. But later, they use different languages to interact with the Spark. Okay, there is a Python community has come. Okay, they also started integrating Python with Spark. That's called a PySpark. Python plus Spark called a PySpark. Okay, because Python community, because initially, whenever I want to work with the Spark, I should know Scala. In the same way, Python community also have come and started integrating with this Spark. They are calling a PySpark. Py means Python, Spark means Spark. PySpark. And there is a Spark is with R. R language is, you can also write a command in R for Spark. You can also write a program using Java in Spark. You can write a program using .NET with Spark. Okay, that's why it's called a multi-language. It's called what? A multi-language engine, we can call it. Right. So now here, when you see, these are more theories are there. The biggest problem. Okay, now it is suitable for real-time processing. What for Spark is being used? It's suitable for real-time processing, travel operations, and processing large data on network. Spark is written in Scala language, Scala, and provides a API in Python, Scala, Java, and R. We can use API. API stands for what? API stands for Application Programming Interface. Application Programming Interface. So you can use some interface to connect with the Spark. So Spark is written in Scala and provides API using Python or Java, or today you can also connect through SQL. Through SQL also you can connect. It helps you to run programs comparatively faster than Hadoop. Okay, you can run a command using in small query you can write, which is much faster than Hadoop. Provides up to 100 times faster. Agar MapReduce, if it's 1 minute, Spark takes 1 second. That much fast. Okay. So as compared to MapReduce, it's 100% faster than MapReduce. Spark runs on Hadoop. You can run on top of Hadoop also. You can also use a Mesos, Kubernetes. Means there are some platforms which you can use. Okay, Hadoop is a platform. On top of Hadoop also you can run a Spark. On top of Kubernetes you can use. You can also run a standalone Spark, I said. Okay, you can also run a standalone, just simple plain machine you can use. Or also you can run in the cloud also, Spark. Okay, you can also run in the cloud. I will give you cloud access to you so that you can run from any place. That command. Okay, so you can use, and Spark, you can see that you can interface with this all. What are those things? You can connect with the Postgres. Means you can read data from Postgres SQL. You can read data from MySQL. You can read data from a Spark, Kafka. You can read data from MongoDB, Cassandra, HBase, HDFS. You can read data. They can all be a kind of a source for Spark. You can also push data to them. Okay, Spark, you can read data from these all sources. You can also push data into output also. Okay, when you are working with a Spark, obviously what happened that there are additional library built on top of a core, allows diverse workload streaming, SQL and machine learning. Spark is designed for a data science and its abstraction makes science. Spark offers over 80 high-level operators that makes it easy to build a parallel applications. And Apache Spark achieves high performance for both batch and streaming using state-of-the-art DAG scheduler. Okay, what I wanted to say that Spark comes with a number of operators. Okay, Spark comes with a multiple operators. Each operator is like a command, like a filter, join, aggregate, group by. There are a set of operators are there, and obviously here why it is say faster, because it uses at back end a DAG. DAG stands for direct acyclical graph. Direct acyclical graph. It maintains before it implements a job. Okay, the moment you submit a Spark job, in memory it prepare a graph. Okay, when you write a job में क्या हो सकता है? What is job? You write input, you write output, you write process. All things you write, right? In job, अगर एक job लिखा, क्या करेगा आप लोग? It read the data, it will process the data, it will write into some output. This is your job. How to read data you are writing, how to process data you are writing, how to write data you are writing. So when you prepare this kind of a job in Spark, when you submit it, it prepares a DAG. Okay. So it prepares a graph. That graph tells you that from where data has to read, then what next, what next, what next. Okay. Suppose if it is fail, okay. For example, I'll give if you see that DAG here, how it maintains DAG in Spark. If you hear DAG operations. Let it come. Yeah. See here. When you write a job here, you are here as an action encounters, it will create a job. Now you write a job. Okay. When you write a job, it prepares this type of this one, graph. Okay. Like which is your source, what operations you are doing, next where are you writing output. Okay. Now suppose at this stage, like RDD, if job get fail here, okay, it's depending on RDD1, RDD2. It will start your data, reading data from RDD1, RDD2. Suppose if your job get fails here, it need not start from the RDD1 and RDD2 because RDD is already there. From there only it will. So it knows from where to stop, how to start, okay, what is the next procedure. So that's why it's like a graph it prepares. It's like what a graph it prepares through which you can, it means internally it prepare a graph. Example, if you see here, another example, how you can visualize graph. Okay. Now you are performing some task, parallelization. Let us take you are reading a data. Then you are filtering the data. After filter, you are performing some task, map. Okay. So the output of that map goes to, you are aggregating the data here. You are aggregating the data. Again, you are performing the task. Suppose if you are same thing, this output of this map goes as a join, input to a join. Okay, here it's going as a input to a join. Now join also takes data from what other map also here. This map which is filtered here, and this is internally you are reading data here. So there are two sources. First, source one you are reading, you are filtering, you are generating output, you are aggregating the data. Again, you are pushing into some join operations. In stage 3, you are also reading data, you are filtering data, you are performing, pushing into a join operations. Suppose if you are join, if you while joining data, if your job get fails. Okay, internally it has a no, it knows very well because of this with this graph. Okay, suppose if you take this graph and suddenly if your job gets at join stage, what you do that? You go, you read data from this map, you read data from this map. Correct? Suppose if the job get fails here, what you do that? You will not start from this map. Okay, it will start from the filter. Because filter is already output is there, you read data from the filter only. Other if your job gets failed in filter, again you read it from the parallelize. So this way the graph is there. Okay, based on this graph, it performs the task. Okay, it performs the task over here. Okay, so that's what it's called a DAG operations we can perform here. That's what here. So the Apache Spark achieves high performance for both batch and streaming data using state-of-the-art DAG scheduler, a query optimizer, and a physical execution engine. So before it executes a job, it prepares. Like before you construct a building, what you do, you will not directly take it. Today I want to construct a house. You will not go directly dig the land and start constructing, right? What happens here? First you plan it. Okay. So how many rooms we need? Room 1, room 2, room 3. Okay. Which is the entrance? Okay. Where is the window? All you plan it here. Once you satisfy with this plan, then implement it. Otherwise, what happens that when you directly start building a house, what happens here? Suddenly your plan may get changed. Okay, again, whole demolition you have to do. Doing that, instead of doing that, you build a plan first. You prepare a plan, like a blueprint you prepare, then you go for implementation. Here also what happened that before it executes job, it prepare a blueprint. Okay, anything is there before it does changes in the blueprint only. Okay, directly does not implement the job. It does blueprint. That's called blueprint is similar to a DAG, direct acyclical graph. Now, these are all features we can see that Apache's features of Spark is you can use scalable, you can like speed, obviously. You can hold the data into a main memory, that's called a caching, you can do it. You can deploy on multiple environment, you can deploy on cloud, you can deploy on standalone, you can deploy on even Hadoop also. Okay, you can use for both real-time and even batch processing. When you see here, that's what here you can see that Apache Spark, when I use this Apache Spark here, features if you see here, features, the first features, batch and streaming data. Means Spark can be used for batch purpose also, streaming also. You can use SQL analytics. You can use SQL for analyzing your data. Then it can be used for machine learning purpose. Machine learning already आपको पता है. पहले we have a data, we have to train, we have to test, we have to. Okay, machine learning operations you can do it. Data science at scale, performance exploratory analytics also you can perform. So these are all few features of a Spark. It is very simple, it's fast, scalable, and also unified. I told you it's a multi-language engine. These are the languages it supports. You can see here. You can use a Python, you can use a SQL, you can use a Scala, you can use a Java, you can use a R. These are all different API that Spark supports. Program is same, Spark is same, engine is same. But whenever you want to write a script to submit to an engine, okay, which language you use is up to you. You can use a Python, you can use a Scala, you can use a R, you can use a Java, okay, you can use even SQL also. Since you know a Python, so we can use a Python. Okay, for different languages, use a different library. When you're using a Python with Spark, internally they use one library called Py4j. Py4j library it uses. Okay, Scala is anyway a default. Scala is a default only. Even if you write a program in Python, it converts at back end Scala program. Because Scala is its own language. Because Spark is written in Scala. But when you're using a third-party language, it doesn't know. Okay? Even if you write a program in Python, internally it creates a Scala bytecode for execution purpose. Even if you write an SQL command, you in Spark, internally it converts into a Scala bytecode. Same thing with the Java, same thing with the R. But Scala, if you write in Scala itself, no question. It is using already uses that Java virtual machine for that. Okay. So now there are, when you are using that ecosystem part, so there are so many things you can use: PyTorch, scikit-learn, Pandas you can use, TensorFlow you can use, R you can use, MLflow, machine learning flow you can use. Even you can also perform some kind of an SQL analytics using Superset, Power BI, okay, or Tableau also you can use at a front end. Now, coming to this part here, when I'm talking about a Spark over here, so features of Spark is a speed, powerful caching, deployment, real time. Okay, so polyglot means the Spark provides a high level API in Java, Scala, Python, and R. Spark codes can be written in any of these languages. You can use language free. It's a language free, means you can use one of the language, whichever you are comfortable. Okay. It also provides a shell in Scala and Python. When you're using Scala, it provides a Scala shell. When you're using a Python, it uses a Python shell. Scalable. Spark is scalable that it can handle growing amount of work by adding resources to the system. Like you know that today I may be using only one machine. Tomorrow I have too many machines. I can add one more machine to a Spark cluster. Now, when it comes to a Spark, very high level architecture of Spark, let me first tell you. Very high level architecture of Spark is this. When I write a very high level architecture, what is the architecture of Hadoop? High level architecture of Hadoop. High level architecture of Hadoop. How is the architecture of Hadoop? We have this is a high level architecture. What is within Hadoop? When I use a Hadoop here, what all things are there in internally? Sorry? Yeah. Sorry? वो platform wise, वो hardware का हो गया. Architecture I'm talking. HDFS first one component, map produce another component. These are the within Hadoop. Okay, that's why it's called a core Hadoop. It's called what a core Hadoop. तुम लोग, I don't know whether what you do in weekdays में आप लोग क्या करते हैं पता नहीं. You have to study. Okay, बाद में we know that the scoop, we have a hive, pig, flume, something, all things. These are very high level architecture. They are called what? Say Hadoop ecosystems. Hadoop ecosystems here. Okay, you can HBase is there and Zookeeper is there. Okay, these are all what? This is Zookeeper, HBase, all are the very high level architecture. From the cluster point of view, how it is? Suppose if you build a cluster Hadoop, what all things are included in the cluster? Architecture point of view, from the hardware architecture point of view, how it is? This is a high level architecture of Hadoop. एक HDFS है, MapReduce है, Scoop है, top of that Scoop, Flume, Pig, Hive, Zookeeper, Woozy, HBase, all are there. But when it comes to architecture of Hadoop is what? We have a, sorry, we have what? Nodes. Master node and slave nodes. Master node is called what? Master node is called what? Name node. Okay. So here master node is what we call it as a name node. Okay. Then here we have a data node. Okay. And which are the daemons? Which are the daemons? Job tracker and here job tracker and here is a task tracker. There can be how many job trackers are there in cluster? How many task trackers are there? Many. Many. As many number of nodes you have, that many task trackers are there here. Correct? This is a high level architecture. And this is a also platform architecture. Hadoop platform architecture. Okay, Hadoop platform architecture. Are you clear with this last time? I think we have spent 4 days, 4 weeks we have spent on this. Still आप लोग understanding नहीं हो रहा है तो let me know. Now in the similar way, how is the Spark architecture? Okay, very high level architecture. Let me first give you the first. It's called what a core Spark. Core Spark. Then there are ecosystems of Spark. Okay, that's called Spark SQL, Spark Streaming, Spark Machine Library. Okay, so here this is called a Spark SQL. Then we have a Spark Streaming. Then we have a Spark mlib. And we have a graphics. This is what a very high level architecture of Spark. We have a core Spark at bottom layer. On top of, there are some ecosystems. Okay, these are all ecosystems. Okay, whatever these all are, what are ecosystems? Spark ecosystems. Okay. So when you have ecosystems here, Spark ecosystems, and this is a core Spark, right? Now, when it comes to a Spark platform architecture, okay, you can have what a Spark cluster. So Spark cluster also can have what a master node. Okay, these are all what are nodes. Okay, and these nodes are connected each other like Hadoop. And here the primary node is called a Spark master, right? And secondary, it's called a Spark workers. Okay, you have a Spark worker 1, Spark worker 2. This can be a Spark worker 2. This can be a Spark worker 3. Okay. And each node has a disk, CPU and memory, like your Hadoop. Okay. And daemons, here it's called a driver program is here. And this is what we can call it as a Spark executors, like a job tracker. It is similar to a job tracker. Okay, here Spark executor 1, Spark executor 2. And this is Spark executors 3. Like this, you have a Spark executor. Spark executors are similar to a task tracker, which execute the task given by the Spark master. And Spark master is the one which is interacts with the client and also interact with the Spark executors. Spark executors. Okay, so architecture more or less Hadoop and this is same. Okay, in Hadoop we call it as a master node, and name master node is called a name node, and data nodes are called, worker nodes are called data nodes. Okay, here also in Spark, the high level architecture, if you see, there is a core Spark, and there is what there are some ecosystems. Now, here when you use this Spark, okay, like this way, when you are in core Spark, we are performing, say, multiple I think when architecture also it is here. It is Spark workers and Spark executors. Okay. Now, this is the architecture we use. Okay, platform architecture is a high-level architecture of Spark. Right here also. Okay, Spark core and Spark core. On top of these are the ecosystems. Spark SQL, Spark streaming, Spark mlib, and graphics. That's what I have shown you here. Okay, Spark SQL, Spark streaming, Spark mlib, graphics. Okay. Because whenever you want to interact with the RDBMS and Spark, we use a Spark SQL. We can also use to work on a structured data. Spark streaming, which you can use to ingest data which is coming continuously. And Spark mlib, where we can perform machine learning operations. We can perform, because there are a lot of machine learning libraries are there. So you can use those libraries to perform a task. And whenever you want to analyze a graph, okay, then we are using a graphics. Graph X. So these are the very high level components of Spark. Okay. I don't know why they are making same thing. Na? Here also the same thing. Because here whatever we have, polygon something. Na? Here we have the same thing here also. Okay. Now, if you look into a Spark history, okay. So Spark, as I said, is developed by whom? Who is a person who developed? You can just see. Sorry, who is the author, or can say co-author of Spark? Already I told you. Who is that? Johariya. Okay. Now, if you want to see now, you can see his photo also. Okay. This is the name. Johariya Metai. He is a person who invented or who developed Spark engine first. Okay. You can just see that Spark. Now it is after he donated to Apache Foundation, then it's become an Apache Spark. Okay, but initially it was just a Spark. Okay, so he developed where? University of California, Berkeley, and later he donated to AFS. AFS means Apache Software Foundation. Okay, now Spark is being maintained by ASF. Okay, now this Spark has become a commercialized. When the Spark has a commercialized, okay, there are vendors. Okay, so who are the vendors for Hadoop? So who are the distributors for Hadoop? Who are the distributors for Hadoop? Huh? Right there. Who are the distributors for Hadoop? Cloudera, Hortonworks, Mapr. Okay, they are all distributors for Hadoop. IBM in that matter. So they use core Hadoop, and plus they use their own features. Like SQL. Okay, SQL क्या है? Originally NC SQL, American National Standard Institute. उनका SQL है. Oh, SQL can be used by MySQL also. MySQL is a database developed by some company. Oracle is also one database developed by Oracle. DB2 is also one database developed by IBM. Ingress, Sybase, these are all different databases. They also use a SQL. But they followed entire, whatever the NC SQL is there, they take all features of NC SQL. Okay, SQL Server is a database from Microsoft. They use this one, TSQL. Okay, TSQL is transaction SQL. So any SQL they use, na different company they use a different SQL, but they use a core features of NC plus their own features. NC SQL plus their own features. In the same way, Hadoop or core Hadoop is there from the Apache Foundation, which everyone is maintaining, everyone is contributing. But if I want to take a open source directly into my production, it's very risky. Because no one is owner, na. For open source, no one is owner. Everyone you can contribute. अगर आपका नया functionality पता, when you study this particular Spark or Hadoop, का नया idea आ गया, you can develop using that particular Java. You can submit. If they validate, they add their features. But when I take this type of software in my production, in my company, if something goes wrong, किसको पकड़ने का? Right? अगर something goes wrong with the crack हो गया software, there should be some person who to whom no you give me and recover and give me. I cannot. So there should be always, whenever we want to go for a say any production, we use a vendor based tools only. Example, Oracle. If I want to use a database, I can use a Oracle, I can use a MySQL, I can use a Sybase, Ingress. Okay, because if something goes wrong, they will help us. Same thing here also in Apache Hadoop ka different vendors are there. That is a Cloudera, Hortonworks, Mapr. Okay. Even Mapr is there, IBM is there. Okay, they all support. They are the distributors. They use core features of Hadoop plus their own features. But they are all supported for only on-premises. Today, okay, everyone has gone to a cloud. If you are unknown to a cloud, you are illiterate today. You should know cloud. Without cloud, no, you can't. Everyone has moved to a cloud. When everyone has moved to a cloud, who are the major vendors for cloud? AWS, Google, GCP, and Microsoft Azure. These are the vendors who are providing cloud service. Okay, they also started providing Hadoop services. पहले कैसा था? हम अमेज़न से ये लेता था. Only give me only a infrastructure दो मुझको, क्योंकि मेरा पास मेरा tool है. When I get an infrastructure, I will install my own software and applications. I will run it. Okay. So अभी मैं क्या कर रहा हूँ? Give me everything. Okay. Give me everything. Give me Hadoop services in Azure. They have a Hadoop services called HD Insight. Agar if I want to go for Amazon, they provide a Hadoop services like called EMR, Elastic Map Reduce. What do you get in Cloudera? What do you get in Hortonworks? What do you get in Mapr? What do you get in IBM? You also get there, but on cloud. No need to bring this software and buy. Means you are paying money for two people. Here, one you are paying money from a Cloudera. Then you are taking a hardware services. You are paying money for them also. So now let me take their service only. Na? You give me that Hadoop services, I will pay you only. किसका तुम अंदर का अंदर डिस्ट्रीब्यूट करो, लेकिन मुझको Hadoop cloud का चाहिए. So I can go for, if I go to AWS, I will ask for a EMR service. They are providing as a service. If I go to Azure, I will ask for a HD Insight service. HD Insight Hadoop services. If I go to a Google, I will ask for a BigQuery. They also provide a Hadoop services. BigQuery is a service. Under BigQuery name, they provide a Hadoop services. Under HD Insight name, they provide a Hadoop services. From Azure, AWS, under EMR, they provide a Hadoop services. So they are all commercialized. फुकट तो नहीं देने वाला ना वो लोग. They are charging money. अगर ये लिया तो यहाँ से डाउनलोड करो, इंस्टॉल करो, सब कुछ चालू करो, आपका फ्री है. क्योंकि बट उसका बाप नहीं किसको. There is no one, you cannot catch anyone, right? It's a orphan. Everyone is contributing here. And if something goes wrong with the production, you can't blame anyone. If I go to EMR, if something goes wrong, I will ask EMWS. तुम्हारा सॉफ्टवेयर मैं लिया, गलती हो गया, मुझको रिकवर डेटा रिकवर हो गए, लॉस्ट हो गया, you recover and give me. They will help you. Okay, so they are the one. Same way, Spark also made a commercialized. Spark also made a commercialized under AWS, under Cloudera, under Hortonworks, under HD Insight, under what say Google Query. They made also one like Pig Hive. When I say Hadoop services, they provide MapReduce, they provide HDFS, they provide Scoop, they provide Hive, they provide Flume, everything they provide. Along with that, they also provide you Spark. Along with that, they provide you a Spark. Is that clear to you all? So we'll take a 10 minutes break. 10 minutes. I'm not giving a full break. 10 minutes only.
So we have to go for 15 minutes.
अभी भी खाया ना तुमने?
Sir, lunch time.
देखो साहेब, देखो, see, to me no problem. I have to complete the task. वो भी है ना मेरा पास. वो मुझको भी 36 hours में complete करने का सब कुछ है. बहुत कुछ है. Let me take 10 more minutes. Then we'll take break. See now, these are all, if you see versions, so many versions are here. Like you can see today, 2016, 2022 is a 3.3 versions. It started where, if you look into 0.6 version, 14 to 12 को हो गया. उसका पहले first version they started what latest version is 0.5 version. Okay, release date is 2012. Okay, but he started project in the year 2009. Okay, so a lot of changes are taken place and all everything over here. Now, okay, this all theory is there too much. I don't want this too much theory. Okay, now when I come to this Spark, there is a fundamental unit of Spark is called an RDD. Okay. Now we know the architecture here. Already how it is architecture. This architecture, Spark master is there, Spark driver is there. Okay. Spark workers are there. Driver program is similar to what? Job tracker. Spark executor is similar to a task tracker. There can be a multiple Spark executors, but only one driver program. Now, your data can be there here, or your data can also come from outside. Okay. Now, I can bring a data here, push data here. Or if I have a data already here, I can also read a data from here. It will get distributes here. Okay. It is just an engine to process the data. Now, what I said is a fundamental unit of Spark is, okay, is called an RDD. RDD stands for Resilient Distributed Dataset. RDD stands for what? Resilient Distributed Dataset. Right. Now, when it is a resilient distributed data set, what is this? So, in Python, if at all you want to hold value 10, how do you do it? Suppose I want to hold, sorry? Come on. How do you do it? For example, int a equal to 10. Is it a?
Yes.
Right. Correct. So, what is this actually? If we give this particular statement, how do you visualize?
We store a integer value 10.
We store a integer value. Okay. So it's called a here. A is a symbolic name. Okay. which holds value 10. Okay, because it's a symbolic name, it's allocating one space, location here, location address hai either. There is some memory location address here. Correct? Are you agree with me? Now, if I make, say, int b of 50, again, same thing here also. Okay, we have a location here, memory location. It's called what? A b. Okay, its value is a 50. Internal value of that value is a 50. Its memory address can be a 500. Memory address is different than what? Memory address is only for reference purpose. Maybe 300 is an address. 300 is an address. 50 is the value. B is what? It's a symbolic name. आपका symbolic name है ना? प्रथमेश. प्रथमेश बोले तो आम बोलेगा. Correct? So that's a symbol identification. Correct? But प्रथमेश is associated with some address. उनका पता है कहाँ से तो store saving is residing somewhere else. Okay? प्रथमेश associated with an address. वो address में क्या है? प्रथमेश is also one of that. Individual. That's a value. Okay? In memory, when I allocate a memory some value, it allocates a space. Its name is A. The value is 10. Its address is different. Correct? So, now, if I want to hold 10, 20, 30, 40, 50, how do you do it? I want to hold 10, 20, 30, 40, 50. इसमें मैं क्या कर सकता हूँ? A, B, C, D, E, F कर सकता हूँ. Right? A equal to 10, B equal to 20, C equal to 30. Okay? ऐसा भी कर सकता है ना? Okay. Here I am declaring a 5 allocation. 5 different places. When I am having a 5 here, what happened that? Okay. What happened here? 5 different values are here. Okay. 5 different names are here. Different addresses are different here. Okay. But they are all distributed. अभी आप लोग कैसा है? उनका एड्रेस अलग है, आपका एड्रेस है, उनका अलग अलग है ना? Right. Now, suppose if I want to access Prathamesh from you, and you have pointed to him, you know his address. Okay. Now I want to access Prathamesh. What I will connect with you. Okay, I know you are not a Prathamesh. So you give me a pointer to that. Hey, I don't know, but you can ask him. So he can give a pointer. So that's what I can refer a memory address here. अगर आप लोग हॉस्टल में हैं तो अगर सभी लोग एक हॉस्टल में, okay, your room number is 100, 101, 102, 103, 104. All are in one place only, right? But all our address are only a hostel only. Okay, it's identified as a hostel. All are staying. So in the same way, under single variable, if I want to hold 5 values, how do you do it? What is that? List. What do you call that list? Generic name. What do you call for that list? List तो आपका टेक्निकल हो गया. टेक्निकली आप बोल रहे हैं लिस्ट इक्वल टू इंटू ब्रैकेट 10, 20, 30, 40. दैट इज टेक्निकल ज्यादा हो गया. बट जेनरिक क्या बोलता है उसको? इट्स कॉल्ड एन अरे. Okay. So suppose if I want to hold here, so what I do that I declare one array. Okay. And this there are 5 locations. Each locations have what? So one value. And it's called I can make it as a here. Okay. So in how do you declare here? Normally, int a of 5, something you declare na? in generic. Okay, I can use different like a 10, 20, 30, 40, 50, something we declare here. Okay, you can declare this way. और आप लोग कैसा बोलता है ये लिस्ट कैसा? How do you make it list in Python?
By using the
A equal to list of
square bracket.
huh. Huh. So means there are 5 locations, but only one identification. That's A. Okay. Suppose if I want to access 40, how do you do it? By using index value. Suppose if I use A of 4, means I will access 50.
Yes.
Correct? If it's A of say 0, I will access what? 10. Correct? So now this array is in Python or in any language. Okay, it is, suppose if I am using this machine, okay, it is here only. It is using only one memory, only one computer, on only single memory only it is allocating. Now, when I am having a cluster means you have so many nodes. Okay, node 1, node 2, node 3, different machines are there. All are connected each other. Okay. Now, if I declare RDD get distribute across all nodes here. Okay. RDD means resilient distributed array. It's not an array on one machine. This array is distributed on all machines. Okay. So your data, when I pull the data from this location, your data get distributed partially in this location, partially in this node, partially in this node, but all belongs to one RDD. That's like an array. Internally, it is distributed here. But I am accessing using array only. Okay, that's what it's called a distributed array. Resilient distributed array is called an RDD. This is a fundamental unit of Spark. Anything you declare, okay, it distributes across all nodes in the clusters. And every data, suppose if you are reading an entire file here, just a file, you take any file. So every line of this file become an element of this array. Every line of the file become an element. You know already element here. These are all elements, right? 10, 20, 30, 40 are elements. Okay. So when you declare an array, it is similar to what? Declaring a single dimensional array. When you're declaring a RDD, it is like declaring a single dimensional array. So now every line of the file become an element of the RDD. Is that clear? So RDD is similar to an array, but array, if you see the difference here, regular array and the distributed array. That array is allocates only a memory on single memory. Here, that array is distributed here. And data also get distributed across all nodes here in the form of partitions. In the form of what? Partition. How many nodes you have? On all nodes, this array get distributed. Here I'm giving an example of only 3 nodes here. When I declare array, on these 3 nodes, the same RDD get distributed. Okay. So this is what the distributed array, what I call it as an RDD. Okay. This is a very fundamental. Now when I create an RDD here, okay, it brings data from disk into main memory. Right. So Spark is a very lazy execution. Okay, Spark is lazy execution. Unless and until you take action, it doesn't execute, it doesn't bring the data. Okay, it's a very lazy execution. Spark is very lazy execution. It doesn't do anything unless until you take action. Right. So now whenever you want to perform any operations on RDD, some operations I have to perform, right, on RDD. Okay. So these operations are called RDD operations. RDD operations. And these operations are divided into two types. One is a transformation operations. And second one is action operations. Okay, there are two types of operations one can perform on RDD. Once you create, I will tell you how to create RDD. Okay, when you create an RDD, I cannot just simply create an RDD. I have to do something. When I bring a data into main memory, either I have to filter, I have to join, I have to split, something I have to do. They are called an operations. Whenever I perform any operations on RDD, those operations are divided into two types. One is a transformation operation. Second is the action operations. So transformation operation, okay, always creates a new RDD. Always. Transformation operation always creates a new RDD. And action operation, okay, returns result. Okay. Action operations, what returns result. So without action operations, transformation operation will not get executed. Without action operation, because action means you are implementing. Okay, that's what I said. You may write hundreds of transformation operations. At the end, you have to take action. Right? There are so many transformation operations are there. And there are few action operations are there. Okay. So transformation operations, I will give a very simple example of transformation operations are, for example, filter is one action transformation operation. Filter, you are filtering the data. Okay. Maybe a distinct, you are removing the duplicates. Maybe a join. Another, you are joining two data sets. Right. So maybe what a aggregate. You are aggregating the data. They are the different. Some operation, you are aggregate operations there. If you are going to aggregate the data, you are maybe some, maybe a count, maybe something you are doing. Okay. So, or reduce. Okay, is also one type of aggregate. These are all few examples. There are hundreds of transformation operations. And there are few action operations also there. For example, collect. Collect means it collects and returns. It collects from all nodes and returns. Count. Okay. What it does, it counts number of elements. Okay. Suppose if you want to save as. You are going to know I am going to collect the data and I will save into a disk. Okay. So these are all few examples of action operations. Action operations. These are a few examples of what the action operations here. Right? So now, okay, what we'll do that we'll take a break. After break, okay, I will discuss about few of them action operations, few of them what are, say, transformation operations. I'll give less focus to what RDD, because more focus is what data frame with structured data. That's today's this one. Okay, RDD is again little older part. In the beginning we used to use. Today we use most of the time data frames. Now it's 13:08. Tell me what is how much time you need to go for lunch and come. 1:30 sharp. So it's around 22 minutes are there. Just go and come. You guys go for lunch. How many are there online?
Yes, sir.
They have given too much theory here. See, same thing. Here, whatever we explain, now here all we do it. In memory computation, lazy execution, fault tolerance, too much theory. One 1:30 I'll start session quickly.
Sir, is Spark clustering is part of a core Spark? Yes, sir. Or is a core Spark? Spark clustering is a core Spark.
Not Spark clustering is a core Spark. Within cluster, this is core Spark is also their bottom layer. Yeah, they have put lot of area. To skip this. Why others are not coming?
नारद मुनि जैसी हो गई है।
स्टैंड पे रखेंगे। हाँ वो स्टैंड होता है ना जो ये वेट पे यूज करते हैं उसमें नहीं होता पेड़ों में बनाने
आ गए
अरे
Okay. So see here, now we're discussing about what say operations, right? So now we need an infrastructure to work with any practical. So let me give quickly the infrastructure. There are two things you can work. One is you can install if required on your laptop. That you have to download and install it. That required prerequisite is what that required Java first. Or if you are working with Python, you have to have a Python. Okay. And secondly, that you can use Jupyter Notebook. Okay. So Jupyter Notebook with Python comes with the Anaconda. How did you work with the, you have that?
We have.
Okay. So that is one part. That's one option one. If you have that, in that case, what you need to do, you have to go to directly to this Apache. Like Apache Hive is there, no? Apache Spark. In this here, you can just simply go to a download. Okay, this is option one I'm telling you, but this takes a lot of time. Okay, another option is I have given you a lab. I mean, Cloudera lab. Okay, in this Cloudera lab, you can open a second one. The second, which is I given here, that 1.5. Here Spark works. Okay, this is the option 2. Okay, this also you leave it for time being. Now you can start this. Same you can do it. Another very important what you can do is that Spark is developed by a person called Joharia. Okay. So Joharia started a company called Databricks. Okay, Joharia started a company called Databricks. Okay, so they have come up with a platform and service you can access through Azure or AWS and all. So he developed a platform. In this platform, okay, okay, if you are using a service from Azure, it's called a Azure Databricks. Currently, we are using that only in most of the industry. And this Spark, which is like whatever the Cloudera which I have shown, is all on premises. That is. Okay, now everything has moved to a cloud. Okay, they are providing on cloud. They are providing a platform. Okay, under Community Edition. Under Community Edition. So they are providing you one single machine, single node machine with 15 GB RAM, which you can use for almost year, 2 years. Okay, whenever you want, you can access it, you can run it, your jobs and all Spark job, you can run it. And whenever it up to 10,000 files, something they have given some limit. अगर आप चाहिए तो दूसरा account पे email ID से you can create it once again. Every time you can create that machine, you can use it for there. You can use all options like आपका R भी कर सकता है उधर, SQL कर सकता है, Spark कर सकता है, सब कुछ कर सकता है. So let us show you that how to get that machine, how to create that machine, and we can go to that machine and always we can work on that. So what do you do? People do it. Just type Databricks. Okay, in net, what to do? Just Databricks. Okay, I think we'll have like a, what did you get this one? Databricks. Okay, when you click on Databricks, you will get like this. Try with this. Databricks, first type Databricks. You will get in the Google and just type data.
We can access this from data because we have already done.
No, this is easy. Yes. This is easy, very easy. You can use. Okay, Databricks. I'll just give this particular link here. You can take it link. Okay, did you get this, all of you?
Yes, sir.
Okay, once you get here, then get start for free. Get start for free. So they will ask you some information like first name, last name, email ID. Email ID is very important here because you will get one mail. Are you able to access mail now? Databricks. Did you type that one? Start for free. Give your name here. First name, last name, email ID, which you are accessing now only. Give that email ID. Just to give some dummy company name, title, operation, some name, some country, whatever you can give it information here. And click on yes. Okay, for example, if I'm giving here, okay, when you click on continue, give you this information. Important here is you type any first name, any last name, we don't mind. Okay, but main is what? Say mail ID. Okay, you select whatever, some name, all those you can, you click on continue. Okay, you'll get like this. Choose cloud provider. Don't select cloud because you should have a subscription for that. Don't do that. Okay, go down. Don't have a cloud account. If you, now you don't, let us take you don't have any cloud account. Okay, community edition is a limited Databricks environment. Okay, for personal use and training. You can use it for personal use and training. So get started with community edition. Click on get started with community edition. Let me know what did you get. So I have created, I don't get it. When I get started with community edition.
Check your email to start your
Verification, did you get anything? No, no?
Yes.
Okay. So now you got a one, check your mail. Go to mail ID. Wherever you have whichever mail ID you are given, go to that mail account. Just check, you might have got one mail from Databricks.
Yes.
Did you get? Hey.
Get started by visiting.
Tell him also what you have done.
Orange get started. Click the database and enter there. The button enter the information to So I got a mail, but there is a mention get started by visiting.
Just 1 minute. Everyone got a mail?
Get started.
Yes, sir. Yes.
Last time also there were only 4.
What's the don't know. Okay.
3. Yeah. 3:30 to go up to, depends on topics in the.
लेक्चर होने के बाद नीचे आना, I want to talk to you guys. ठीक है? यहाँ से आना. सर मैंने आपको एक मैसेज किया सर, उतना आप मेरे को बता दो।
हाँ मैं बोला थी कल खत्म करने को बोल रहे थे ना। हाँ आई डोंट थिंक कल अभी अभी स्टार्ट किया स्पार्क।
हाँ
कल मुझको खत्म करने को क्या प्रॉब्लम है, मैं खत्म आज भी कर सकता हूँ, इतना नॉट अ प्रॉब्लम, बट इफ दे आर एबल टू गेट गुड ना।
हाँ, मतलब कितना कंटेंट बाकी है अभी ये लोग का?
आज तो ये स्पार्क चालू किया उनका एज पर योर शेड्यूल। आज स्पार्क ओनली स्पार्क है वो। आज कल एटलीस्ट मुझको अगर इफ दे वांट टू नो मशीन लर्निंग एंड ऑल 3 दिन में बोला था, 3 दिन बोला था ना, 4 वो 36 आवर्स का था ना, कितना था आपका?
अभी कितना टाइम है?
हाँ अभी कल और परसों ना, दैट आई कैन कंप्लीट।
And what about Monday?
हाँ मंडे वो अभी वो जस्ट डिस्कस करने का है उनका साथ वो।
ठीक है, आप मुझसे एक बार बात कर लो और मुझे एक एग्जैक्ट अपडेट बता दो।
हाँ
बिकॉज मुझे फिर बाकी का प्लान करना है ये लोग का।
मंडे आई विल कंप्लीट फ्रॉम माय एंड, आई विल कंप्लीट नो तो प्रैक्टिकल वो लोग करना पड़ेगा ना, आई विल फिनिश फ्रॉम माय एंड।
Yes, come and meet me, no?
Yeah, so you might have got mail this year, so click on that mail, that link, you will get a community.cloud.databricks.com. Cloud, no, don't go to cloud provider. I told ना, community edition को जाओ। हाँ, you give your own password. Your mail ID is your username. Your username is your mail ID. Okay. My mail ID is this. I use my mail ID. Okay, and my password, anyway, I have set my password. You can set your own password. Login. This is a cloud based they are giving you. Okay.
So I got this type of.
Yeah, that's what I'm showing here. Okay. Quick here, even I have a time to complete, otherwise I should not be a hurry. First अपन टी ब्रेक के बाद जल्दी आने को, then I will complete. आप लोग, I know that 38 लोग को आया था, 130 को बोला 138. So it should not happen this way. And whenever that assignments are given, you have to practice at home. नहीं तो रामायण होता है बस। क्योंकि मेरा कंटेंट सी मेरा आई एम लिटिल, अगर वो मेरा स्टूडेंट है तो मैं बहुत स्ट्रिक्ट कर रहा था, क्योंकि मैक्सिमम यूटिलाइज करो मेरा, बस टाइम मेरा इतना है, तुम लोग यूटिलाइज करो ना करो इट्स अप टू यू, बट मेरा रिक्वेस्ट है तुम लोग, मैं है तो कितना दिन है उतना दिन रिक्वेस्ट करो, यूटिलाइज करो।
मेरे को मिला है सब एक्सेस ट्रेनिंग के ऊपर।
हाँ
आपको ना ऐसा मिला
क्या है वो मेल, क्लिक करो ना, एक्सेस क्या है वो? No, I think
something wrong.
you might have selected subscription AWS or something.
Yeah.
You should not select AWS, or you select the last. That's what I'm telling you. Come early. I have shown you already this. Okay. So now all of you got it this way. So now this is an interface for this. I will give a just very quick demo on this. Okay. So how it is. Since they provide your, okay, this बाद में करो आप लोग, otherwise तुम्हारा divert attention इधर नहीं उधर नहीं. I don't want to be that. ओके बाद में करो, अभी टाइम है तुमको, जब चालू करता हूँ उस वक्त कर देता हूँ तुमको. Okay, so now they, as I said you, they have given you a one platform. Databricks is a company. They have given a platform. The co-founder of Databricks is the co-author of Spark. Please do remember this. Co-founder of Databricks is the co-author of Spark. Okay, now he has given a platform. One machine they have given you. This machine has, okay, 3 layers. Okay, this machine has what? 3 layers. So, and first layer, okay, is what? It's totally, it's called a workspace. Okay, workspace it's called. Workspace means like a desk space, workspace tum log bolta hai na, work where you are going to work. It's like a workspace. So here, this is called a cloud service. Okay, it is called a cloud service, or can say cloud layer, can say cloud layer, and this is called a storage layer. Okay, middle layer is a Spark. Okay, middle layer is a Spark. Like whatever आप लोग cluster build हो रहे हैं ना, they give you single node cluster. When I say single node, physically they will give you one machine, but अंदर आप logically divide कर सकते हैं different nodes. Okay, so this is actually a Spark. Okay, let us take, you have some, you have 3, let us take, this is what your cluster, 2 or 3 nodes. Okay, now this ready-made Spark is given to you. Okay, now here through this Spark, when you are creating a cluster, you need some infrastructure, right? Somewhere else. Okay, here you have some services here. Like some services are like one is a worksheet service, worksheet. Okay, where you can write your queries. They provide you a notebook. Then there is a compute service. आप लोग उधर है directly, वो उसमें आपको है उधर. Then you have you can also schedule your job. Okay, then you can also do a data upload bhi hai. You can also upload your data into their local system. So these are all different services are there. Now you need a cluster basically. Okay, in order to need, if you want to create a cluster, okay, I think you have gone through this, all of you have this. Now here there is a compute. When you click on compute, since it's for free, they provide you a one node cluster, I said. Okay, click on create compute. You give your name of the cluster, whatever name you can give it, my cluster, something you can give. Okay, when you give a my cluster, don't do any changes. They have their own platform, Databricks platform. Here you can see instance, free 15 GB memory. As a community edition user, your cluster will be automatically terminate after in an idle period of 2 hours. Agar if you are not working for 2 hours, automatically they terminate the cluster. Okay, again tomorrow you can access, or whenever you want to run it, you can run it. Okay, so only this part, as per this diagram, only this part terminates. Okay, this part will get terminated, but this is there, this also there. You can, whatever jobs you create, you can save here. Whatever data you upload, you can keep here. Only this temporarily this compute cluster, this cluster is you are using for computational purpose. Only computational purpose you are using. Okay, so whenever if you don't work for 2 hours, this will get terminated. Again, next time you start it, you read data once. Your query is there, same query will get executed. It will get executed. Now you can create a cluster within few minutes. Cluster get created on somewhere else in some zones are there. So you can create a cluster in US West 2B. This is a zone where the cluster get creates in few minutes, maybe not more than 5 minutes. Okay, let it create a backend. Now coming to this part, data part. Okay, so data part means whenever you want to upload your source data. Okay, now for example, I want to update a source data. Some data I want to upload. Like I have some data. Let me just take it, any data, whichever you want to do. I just your machine learning का data रहता है ना. So you can take that data also. You can upload. Okay, in the this one. Let me upload one small data here. Okay, these are all files. Download. Is downloading. Yeah. Now what I will do, I will just share this material to you people, so you can this data also you can use it. What is that? Forward. Yeah. For the Prathamesh, na? Please circulate to others also. These are you have a class and this one. This one is there here. Back to this. Here I will give you one part. It's very important. So forward to others also. Click. Okay. Let me check. Let me know whether you are issued or not. Okay. Now I have downloaded this data. Okay. This all sample data is there. I can here. So I'll just simply one file I will upload. Like there's a post purple cow has only 4 lines. Okay. This file I will upload into. How to upload I'm just showing you. This is my path. When I go to here data, okay, I'll click on create table. Okay, drop files to upload or click to browse. Click on browse. Okay, then I can just give my whatever that path here. So I'm, oh, it is totally 1 minute. I'll first unzip it. Because whole file will this one. Yeah, this is a upload. This is a file which I have unzipped it. So what I do, I will upload it. Click on once again. Okay, this is my data. Then I will upload simple file. Some files I will upload it. Okay, here some files are there. Okay, just sample file. Let me upload. Okay, uploaded here. So why it is giving a people -2 now? It's already my files are there. So second time it copies now. It makes it overwrites. It doesn't overwrite. It creates one more. There 2, 3 something. Okay, these files are uploaded, and just please see the path here. This is the path. These are by default files are get stored in tables. Okay, these are all cloud part. This I'm telling the cloud. Okay, now to know these all files where they are, click on data. Okay, click on here DBFS. When you click on DBFS, this is a file where files are here. Tables. These are all files are there here. I have downloaded. See one I have uploaded multiple times. So these are the files. If you click on any of the file, this is the path you will get it. Are you clear till here? This is the path you will get it. Right. Now, this is about a data. You just whatever data as a source data, suppose मशीन लर्निंग प्रिडिक्शन का करना चाहता है, मुझको डेटा है मेरा पास, उसके ऊपर मैं मशीन लर्निंग करना चाहता हूँ, तो सो यू कैन अपलोड दिस प्लेस. इट्स लाइक योर हार्ड ड्राइव में अपलोड करता है ना, वैसा ये अपलोड हो जाएगा डेटा. देन योर क्लस्टर देखो, इधर क्लस्टर इज रनिंग नाउ. देखो सिंगल नोड क्लस्टर इज रनिंग हियर. Okay, there are 2 cores here, 2 node cluster it is. 2 core means 1 node. 2 core means like कितना में dual core रहता है ना आपका CPU. Dual core लैपटॉप में तो क्या है? What is the meaning of dual core? 2 processors are there. It means that you can create 2 machines. Okay, so now here also this is also 2 core machine. Okay, they have given you. Now how to start? Now you have created this is only one time job. You can do it in the beginning of your practical. You have uploaded one time all files. Whenever you want to upload, you can upload it. Now come to a workspace here. Okay, in the workspace, okay, you can write your queries. They provide you with the Jupyter notebook. Okay, now if you want to write a query, anything query, go to workspace. Okay, right click, create. When you want to create, here there is a create notebook. Okay, when you create is there, create notebook, you can create folder, you can create libraries, you can create a ML flow experiment also. Now, same thing, import. You can also import some of the files from outside. Okay, some files from outside you can import also. Okay, now first I will show you create. Then one file I have given you Python. For second mail I have sent you Python. Okay, so first I will tell you, you click on create notebook. When you click on create a notebook, it will ask you a name of the notebook. Okay, so this is like my first notebook. Example I am giving you, my first notebook. Okay, when I give my first notebook, now which is your language you want to use? Okay, so default language you want to use for this notebook. Since you people are Python, you can use a Python. Means all command you have to write in Python. If you are going to write a SQL commands in Spark, okay, so you can use SQL. If you want to write a Scala, R. Okay, now I will use a default language is a Python. And this particular notebook, you have to attach to a cluster for execution. So this is your cluster. You are attaching this notebook to this cluster. Means whatever, if you submit this notebook, you are submitting to this cluster. Okay, the cluster is a 2 core machine. Now click on create. When you click on create, your notebook is here. This is your start. Your Spark starts here. Whatever commands you work on that, whatever the Cloudera have given you, the same commands you can work over here also. Okay, same commands you can work. You can create RDD, you can create a data frame, you can create all those things over here. Okay, now coming to I'll give just as I said an RDD part. Okay, RDD. So RDD, what is RDD? Resilient distributed data set. Okay, it is like a distributed array. Okay, it's like a distributed array. So I have how to create RDD. It's very you can, if you let me quickly go through here. So Spark operations I said. Okay, Spark operations are what? Say there are two types of operations I said, transformation operations and action operations. RDD in Apache Spark supports 2 types of operations, transformation and action operations. Now, like if you see that RDD, you can create an RDD. On this RDD, it can be a base RDD. On top of RDD, you can create one more RDD. On top of that, you can create one more RDD. On top of that, you can create one more RDD. Like this, you can create multiple RDDs using transformation operation. If you see my definition, transformation operation creates new RDD. Okay. Now, if you want to return the result of this RDD, you have to use the action operations. Okay. On the same RDD, you can use the action operations, which returns result. Right. So let us see what are the transformation operations, what are the action operations. Very quickly we'll see, and we'll see more on what same thing will be a data frame also you can see. I told you already that Spark is a lazy execution, lazy evaluation. Unless and until you take action, it doesn't execute. You have to take action. Means there are set of action operations are there where you have to use that. Like simple example, a collect, count. You have to use, otherwise it doesn't return the result. Right? So Spark uses a lazy evaluation to reduce the number of passes. It has to take over data by chaining operations together. Okay, you can use as many operations you want. You can use it. Say I told you that in MapReduce you write 100 lines of code. I think one example I have shown you about a word count. So that word count 100 lines become just one line here. By using multiple transformation operations and action operations. You can make one line. The entire 100 lines become one line here. So the coding is drastically reduced. And execution is very fast because it's 100% faster than what a MapReduce. Right. So RDD data does not get loaded immediately. Neither any of the transformation actually gets instantly computed till you can call an action. Until you call action, it doesn't execute. Okay, so the data is not loaded until it is necessary, saving memory blocking in advance. It doesn't save also. Your data is here only. Okay, your data is resided in this place only. That is in the source. Okay, your data is here. But data will not bring them into this layer. Okay, even though you have created a transformation operation, it just allocates a memory space, so data will not fetch. Data will fetch from the bottom only when you take action. Otherwise, it doesn't fetch. Right? So for that, you have to use the action operations. You have to use the action operations. So now coming back to here, what are the action operations? We'll see that. Again, transformation operations are also divided into two types, narrow operations and wide operations, wide transformation and narrow transformations. I will tell you what is wide operations and narrow transformation. See here, like whenever you create RDD, for example, I have a node 1. Okay, this is a node 1. Node 1 has, say, for example, sorry, this is a cluster where we have a RDD. Okay, which is having 3 partitions. Okay, so this is having a, let us take, these are all what are 3 partitions. RDD, because when I say RDD here, I think you can see in this example, this RDD is distributed across 3 nodes. Right. So here also RDD can be divided into, okay, some divided into across 3 nodes. Okay, and that's what in the form of partitions here, like PRT1, partition 1 or partition 0 here, partition 1, partition 2. These are the partitions. Some data is in this partition, some data is in this partition, or some data is there in this partition. Now, if you use some operations, okay, for example, if you use, say, group by operations, simple, I'm giving a very group by operation. When you use a group by, let us take, we have a customer data and there is a city column. In the city column, we have only 2 city. So if you are grouping based on city, automatically it makes only 2 groups because only 2 cities are here. Okay. So when but data is scattered over across all 3 partitions. Example, if you take a simple example is that I have a customer ID. Here, cust ID is there and cust location, customer location. So I have customer ID 1. Okay, customer location is Pune. Customer ID 2, Mumbai. Customer ID 3, maybe again Pune. Customer ID 4, Mumbai. Customer ID 5, Pune. Customer ID 6, Pune. Let us take, we have a data here like this. Suppose if I am grouping based on city, how many groups will be here? 2 groups. Okay, if I want to count, okay, count number of customers in each city. What you will get answer? You will get what? How many Pune is what? 1, 2, 3, 4. 4 Pune equal to Pune is 4 people, and Mumbai is how many? 2 are there. Like this, you will get it. 2 groups. So let us take these are the 2 groups here. But your data is there. Some data is here. Pune here 1 Pune, 2 here 2 Mumbai. Here it can be 3 data maybe scattered here. 3 Pune, 4 Mumbai. Data might be here 5, maybe a Pune, 6, also Pune. Your data is scattered here like this. Now I am grouping based on city. So this can be a Pune city. This can be a Mumbai city group. Okay, it can be a Mumbai city. Now when it's a Pune city, what happened that data will transfer from here. Data, so Pune, data also transfer from here. Data also transfer from here. Data also transfer from here. From this partition to this partition. When you are grouping data. Operation is what? A group. You are using a group by city. Okay, group by city you are making. So the operation is what? One is a Pune, and here Mumbai data will come from this location. From this partition, data will travel to here. Data will also travel to here. Okay. Now, what I'm trying to say here is that, so this is your source. This is become a child. This is become a parent. This is become a child. Okay. This is become a child. Now, I said there are 2 types of transformations. One is a wide transformation. Second one is a narrow transformations. This is an example of a wide transformation. Group by is an example of a wide transformation. Now, here when I say wide transformation, let us see how to put a definition. So parent, as I told you, this is a parent RDD because it's source. From here only you are generating a new RDD, right? So this is a child RDD. The partition of a child RDD, can referred by multiple partitions of parent RDD. Okay, the partition of a child RDD is referred by multiple partitions of a parent RDD is called wide operations. Wide operations. Now this is a partition of child RDD. So this partition of child RDD is referred by all 3 partitions of the parent RDD. Okay, so this also Mumbai is another partitions here. So Mumbai, this is also a partition of child RDD, which is being referred by multiple partitions of child RDD. This is what I call it as a wide operations. Wide operations. Now there is one more operation called a narrow operation. Okay. So in case of narrow operations, so what happens? So again, same example, let us take it here. So we have a 2 part. One, this is in RDD, we have partitions. Let us take, we have 3 partitions here, like this previously. And this is what I can call it as an RDD. Is an RDD. Now, when I filter the data, okay, I will filter it. So now I will filter based on what, say, I may be putting a command like I will take only data whose city equal to Pune. Okay. So what it does, it creates some more partitions. Okay, maybe same number of partitions here. So each data will go to next partitions. Okay, each data will go to a next another partitions. In case of filter, here like this, it is not shuffling. This data will not come here. This data will not go here. There is no shuffling data between multiple partitions, right? So this filter is an example of narrow operations. Filter example. Filter is one command which is an example of a narrow operations. Now, how do you put a definition here? Narrow operation means the partition of a child RDD referred by only one partition of a parent RDD. Not multiple partitions. Here is only one. This partition is being referred by only one partitions of the parent RDD. That's called a narrow operations. Okay. So wide operation and narrow operations. So this is what how we can narrow operations and wide operations. This is an example you can see. The same. Wide operation means your data get shuffled between multiple partitions. In case of narrow operation, data will not get shuffled between multiple partitions. Is that clear? Now, here there are so many operations I said. Okay, some of them are wide operations, some of them are narrow operations. We can also call some of them are action operations, some of them are transformation operations. What a transformation operation does, basically it creates new RDD. Action operation simply returns a result, nothing else. Okay, so these are all what a transformation operation like map, filter, flat map, map partition with index, sample, okay, and group by, okay, so group by, reduce by, aggregate, sort by key. So these are all what through these you are creating a new RDD. You are creating a new RDD. But see, these you are creating a new, this transformer operation also can be a what wide operations, or it can be a narrow operations. You know already wide operation data gets shuffled. Just very simple terminology. What you can do in case of wide operation, data gets shuffled between multiple partitions. In case of narrow operation, data will not get shuffled. Okay, so these are all various transformation which you can use. Okay, transformation like join, co-group, Cartesian product, union. Okay, these are all few operations. Pipe, coalesce, repartition. So these are all what a few transformation. These operations when you use, so using these operations, you will create a new RDD. Using these operations, you will create a new RDD. Very bottom layer, I'm talking about bottom layer, core Spark I'm talking. Not I'm talking about, say, ecosystems. Core system, core, if you look into this diagram, okay, so RDD is I'm talking about only core Spark here, core Spark. In core Spark, we work with only RDD, which is very close to hardware. Which is very close to hardware. Array is very close to hardware, right? Array, when you create an array, you are directly talking about a memory address and element, index number, all those you are talking. It's very close to hardware. There is no data structure there. There is no data structure. I'm not defining a customer ID, customer name like your table. Very close to hardware here. So whenever you are working with, okay, core Spark, you are working closely with the hardware. When Spark has developed in the beginning, okay, in the beginning Spark has developed, that time there was no ecosystems. There was no ecosystems. Because what we have got today Spark is so many inventions are there. So many pages are there here. Everything is what we have today is a scene. Also we have seen when they started a Spark. No. They started with some raw part. That's a core Spark they started. Now, whenever you want to work with even same thing in Hadoop also, they have not started directly with the Hive. They started with the MapReduce first. Okay, when they know some limitations with the MapReduce, okay, because of MapReduce requires a lot of programming knowledge. Because of MapReduce requires MapReduce knowledge, so I may not be able to address large audience. When I'm not addressing large audience, then what is the use of this my system? Then they introduce something new on top of that. So people from non-programming background, like Hive required any programming language like a Pig and Hive, Java and all, not required. Just if you know SQL, like a people like a data scientist, people like a business analyst, people like a report builders and all, they have only SQL knowledge. They don't have any Spark knowledge, or they don't have any very core knowledge of programming. They want to work with the big data. So they using Hive, they can analyze the data, right? Using analyze, that's what later they introduced. Here also when they started a Spark, in the beginning, they introduced core Spark only. In the beginning, they introduce what a core Spark. Later, when they want to address to a larger audience, working with a data structure, okay, data structure, then they introduce Spark SQL. Okay, using Spark SQL, they can work with the data structure. They can work with the data structure, right? So now, is that clear to you all? So there are so many. I will give an example. I'll show some of the RDD operations. Then I'll have a list of RDD operations with program. I will give it to you. Small exercise. Very 4 line ka program hai. So write karo, exit karo, see, analyze it how it is. Okay, that's all. So, but that's what I'm not going to do. I want to focus more on data frame. That's very important. Okay, today we are working with data frames only, with the structured data and all. Okay, so I'll show a few examples of RDD, how to create an RDD and all. So going back to this, I think I have given you these are the data, right? I have given you a data. Then I have also, what is that I have given you here? Some Spark. This I will show later. This part, the first part. I will just go to this day 2. Okay, here. Day 2, I will download it. This is not there. Day 3 is also not there. Day 1. Do you have any day 1 part here? Here, day 1. Here, then. Day 1. Day 2 class. It is there here, and let me download first. Day 1 lab zip is there. Day _1 lab zip. है ना? So वो open करो आप लोग. Okay, when you open that, so go to your download. Okay, day 1 zip is there. Here I will unzip it. Okay, when I unzip it here, I think you will get things here. I'll give a very few examples. Then this is the code you can try at home. There's so much code is there here. Look for each. Okay, for each, like how map works. Okay, it's all in Python only. Okay, there are so many operations you can do a practice on this. But before this, very simple to understand. You know that there's a purple cow. Okay, there's a purple cow. So let me open this notebook. Okay, now see here, whenever you want to start Spark, okay, I'll just few, and also I'll tell you that how it can be done in one line also. Okay, just here, whenever I want to read a data, okay, if you look into this example, in this case, I want to read a data. First, my request goes to where? My request goes to Spark Master. It's like a name node. Okay, then this request, there is a driver program here. So there's an entry point here. Okay, entry point is called Spark context. In short, we call it as a SC. Like in Java program or Python program, how do you start Python program? वो तो है, library import करेगा बाद में. Do you have any starting point of Java program, Python program? Do you know C? वो import हो गया. Any like Java में public class रहता है, देखो Java. Do you know Java? अच्छा. हाँ नहीं. For example, if you know C language, do you are aware? हाँ, C language main use करता है ना, main program, main into bracket. Because when you are entering, so that's your entry point. In the entry point, you can write all things. Like in Java also, we write a Java class. First public class. Then within that, we invoke a subclasses. So here, the entry point is a Spark context, we call it. It's an entry point. Okay. घर में घुसने को एक entry point चाहिए ना. So this is what a entry point. SC is called a Spark context. Okay, Spark context in short form, we call it as a SC. So anything, any command you use, you should begin with the SC. Okay, now, as I said here, first SC text file. I'm going to read a text file. Okay, I'm going to read a text file. So what is a text file? The one I showed, a purple cow.txt. Just now I have shown you, which I have uploaded, right? The same file, which has just 4 lines, which has 4 lines. So after reading this particular file, I am creating a one RDD called my data. My data is an RDD. My data is an RDD, and this is a SC dot text file, and this is the path. From there, I'm going to read a data here. If I take this particular command and go to my, what is that here? My first notebook. Okay. This is the already path is there here. Already I know that where I have downloaded it, I have uploaded a data here. Okay. Here I have uploaded a data in the source file, tables. Okay. You can see a people one, so many things are there. One of them is a purple cow. Purple cow dot txt. So this is the path. Okay, this is the path. So this path I am using to read this file. Okay, in my notebook, I am using this path. Okay, again, this is the path. When I read this path, just execute this statement. Okay, directly run shell. So it is reading. It executed. It created RDD. Backend it created an RDD, but did it? Now you are reading a file, but are you able to see a data? No, because it just simply allocates a memory space. Okay, and it is pointing to that particular data. Now, if I want to execute this data, what I do that I have to take action. So when I take an action, the simple action command is a count. For example, I want to count a number of lines in the file. Okay, when I take this my data dot count, so here if I run it, it counts number of rows. Okay, there are 4 rows. Every line of the file become an element in the RDD. RDD, I said it's like an array. One line is one element. Second line is second element. Third line is third element. Fourth line is a fourth element. If I want to count its number of elements, then I use a RDD name dot count. Suppose if I want to see the data, okay, here you cannot see the data, right? You have to take action. So now if I want to use for see the collecting the data, we use a collect here. Collect is an action operation. When I use this action operation, so here I can see the data here. This is the data. Okay, this is the data. Now, this is one, I'm just reading a file and taking action. I'm creating one RDD. From RDD, I'm just counting number of elements, or from RDD, I want to return the output. Nothing else I'm doing. Now, suppose if you want to do further operations, what are the operations? How many types of operations are there? 2 types of operations. One is a transformation operation. Second one is a action operations. Now, let me just tell you that I brought a data into a main memory. Now I want to filter it. Or I want to convert every line of that file become a uppercase. In order to convert from lowercase into uppercase, there is a function called a toUpper. Okay, toUpper is a function. Now what I'll do that, I read a data from my data, RDD, because that is my source. Then I use a map function. Map is a function in Spark. Okay, what map does? It applies a user-defined function on every element of a previous RDD. It applies user-defined functions. Here, user-defined function, user function means upper function. So this upper function will apply on every row of the previous RDD, every element of previous RDD. Right. So here, that's for which we use a map function. Okay, you know already this lambda in Python. I am defining one variable here called a yes. Okay. So here what it does, whatever element of this my data, okay, whatever element of this my data, where is this? Here. Whatever element of my data will be assigned to a yes. Correct? And upper function I'm using. What it does, upper function? It converts into uppercase. Okay. Whatever element comes, it converts into uppercase. Second element, second element. Third element will convert into uppercase. And that output I want to store into where? Another RDD. My data underscore UC is a new RDD. Okay. Because I'm creating a new RDD based on a transformation operation called map. Right. So now I'll take this particular line. Okay, go over here. Go to a new set of what here. Here I'll just anyhow I have already created this my RDD. Automatically what happened that see now the moment it brings data, the moment collect operation is over, it releases from the main memory. It doesn't hold into main memory. Yeah, data will not be hold into main memory. RDD get created. Data, when you take action, data will travel from the disk into main memory. You print the data here. The moment action is over, so release the data back. Again, nothing is there in main memory. Right. Now, when you use this command, okay, when you use this command, the first it has to get execute my data. It will go back here, my data. Okay. So my data means that here I am reading a data. Once again, I am reading a data. Then it brings a data, then I convert into an uppercase and then temporarily stores into what my data underscore UC. Okay. And that data, if I want to see, okay, I can also see the content. So now run shell. Okay. It executed this statement, but data is not yet transferred. Data will get transferred only when you take action. Otherwise, no. It allows my data underscore UC is another temporary location. Okay, So first what happened that here in the, as per this diagram, okay, so here it's created a my data. Okay, my data means it had just allocation of memory. Then on top of that, when you use my data underscore UC, on top of this, it creates a one more RDD. Okay, on top of that, it allocates a memory space. It creates, this is become a my data RDD. Okay, this become a my data RDD here. My data, sorry. My data underscore UC. UC will be there. Okay, but still your data is here only. Yeah? When you take action, then data will transfer from here to here first. Then from here to here. Okay, so now it allocates a memory space. No data is get travel. Okay, now when I take action here, how to take action? Now if I want to see or if I want to count, okay, I can just simply my data, sorry, my data underscore UC dot collect. If I want to use, okay, I can just run this. Okay, you can see here the data got converted into an uppercase. Okay, again data get released from this memory. Temporarily it brings data. Otherwise it has to manage data. Big data maybe having a petabyte of data brings here. If it holds into main memory, what about other transactions? It will release from the main memory. Now, one more operations I can perform. Okay, now I want to filter. Okay, I'll take whatever data comes in the my UC. I want to apply a filter here. How to filter? There's a function called start with. I want to take only those data whose element of a previous RDD start with I. Okay, because my data underscore UC, you know that what is all 4 lines with the uppercase. Okay, as per if you see this here, these are the line 1, line 2, line 3, line 4. These are the elements. Now what I am going to do, I want to filter a data. We'll take only those data whose line or element begins with I. Other than I want to eliminate. Right. So here I can use a filter operation. Filter is also one of the transformation operation, but this is a narrow operation. It's a narrow operation. So now what I want to do, filter lambda s colon s dot start with I. So I can use this particular, and then I want to hold into a third RDD. Third RDD that is named, that's called what? My data underscore filter. So when I use this here, third in the next line, when I go to here, okay, I can run this one. This one, right? I can run here. It's done. But still data is again in the bottom only. I have to take action here. So what is how to take action? I can take here action, my data dot collect. Okay, my data dot collect. Collect means you are collecting data from all nodes and sending to a standard output device called a monitor. Okay, what was the error? Collect, run it. So here what is that? Only 3 lines which begins with I. Okay. Now you have seen what this one I am just showing you as part of a training. But I told you that this is an interactive mode I am doing. Right. So otherwise, what I can do entire things in single line. I'll just go here. Entire things I will go to in single line only. First, I use, sorry. So this is my first one. I read the data. the output of this, okay, where I will pass it to where? I will pass it to upper. Output of like function within function you use in most of the programming language, and SQL also use no function within function. So here, first I will read a data. The output of this I will send it to a next RDD. Next operations of the RDD, that is uppercase. After converting an uppercase, next is a filter here. I use there is filter. I will use, I take it a filter over here. This is my filter. So this filter, I can do this. I'll do a filter, right? After filter, what I do that, okay, I directly collect here. Collect, directly I will collect. In one line only I will write everything. What it does, it first it entry point is SC, Spark context. It get inside, it reads the data, which is a purple dot text from this particular path. Output of that, it will send it to a map function where it applies a user-defined function. And that's what we are converting into an uppercase. That output will go to a filter where I'm filtering, which begins with a I. And after I am going to collect the data. One line only I can write a program. Okay, I'll just one line, I'll write it. So in the same thing, if I want to do in MapReduce, 100 lines, more than 100 lines program you have to write. Here I'm writing just one line code here. One line code. Okay, as I told you, there are so many operations you have to perform. There are so many operations you have to perform here. So in the same way, if you want, okay, like if you want to perform any this one, some more operations if you want to see, like you can go through a word count problem, will just show it how it is. I think you can realize in word count problem which I shown on first day. Okay, 3 functions, word count dot Java, then mapper dot Java, reducer dot Java. So that I can write in one line. In one line I can write it. Same here. Okay, so now let us see one more operations here. Some more operations, let us take it. Here some more operations you can just see here. So these operations are considered to be what? Like you know that in most of the RDD, union is a function, means which 2 RDD you can union. Okay, subtract is another function you can use. Subtract operation you can use. Subtract means minus, right? So there are 2 data sets. Okay, and if you want to the data which is there here but not here, that you are using a subtract. I think you people are engineering students. You know what is set differentiation and set union. Union pakada pata hai. First, if I have 2 data, say either 5 records hai, either 5 records hai. Agar if I use a union operations, 5 will take first here, then append these 5 records. So output would be 10 records. Okay. Now if I use a set difference, what happens here? Set difference में क्या होता है? दो set है तो data. Sorry, common records. Correct. So common records. So either भी 2 set है. Here I am talking about RDD. Here RDD में some data is there. In this RDD also some data is there. I use a set difference. Commonality between these 2 data sets only it will. Okay. So these are all operations we have here. Right. So here the first, I think the important thing is that I can import libraries. Here also like how you are using like libraries in any language, your Python, some related library with PySpark. That's okay. You have to import libraries. So then I am creating a RDD here. Okay, RDD1.sc. Parallelize is a function. Okay. So if I use without parallelize, data will not get distributed. Okay, data will not get distributed without parallelize, like a list command. In Python, you use a list, na? So you can use a list. List is not distributed data. List is there on one machine. When I use a parallelize, the same data will get distributed. Okay. So in this RDD, how many elements are there? Chicago, Boston, Paris, San Francisco, Tokyo. Second RDD has how many? San Francisco, Boston, Amsterdam, Mumbai, okay, McMurdo and Station. These are the two RDDs. Let me create these two RDD first. When I create this two RDD, when I go to here, go to a new line, then we'll come back to what say word count problem. So then you will understand very clearly word count. So now I can just put all here. One shell is there. I can previously I executed only one command, but I can put all shell commands in one shell only. That's also work out. Okay. Now let me execute this command. So I'm creating a 2 RDD here. Okay, 2 RDD got created. Now, how to see whether the records, these elements are there in first RDD? How to see? RDD1 में क्या-क्या element है? कैसा देखने का? RDD1 dot collect. You can just see here. RDD1 dot collect. So you can see these are the 4 elements, comma separated: Boston, Paris, San Francisco, and all. Same thing with RDD2 also. Okay. Now we know that there are two RDDs. RDD has 2 data sets. Now I can perform some operations like union. Okay, when I want to perform a union here, this. Yeah, union if I want to perform, it's very easy. RDD1 dot union of what? RDD2. Okay, union is an operation. And that output I want to collect it. Okay, so RDD1 dot union and output I can collect here. Okay, just take it here, run it. Okay, here Boston, Paris, San Francisco, Tokyo is from RDD1. Then San Francisco, Boston, Amsterdam, Mumbai from the second RDD. Okay, union is an operation which takes data from first RDD, appends with the second RDD. Same thing if I go to a next one. Okay, if I go to a next one, subtract. Okay, subtract means commonalities, right? Commonalities are what is this? What it does?
It will not select a common.
Does not select a commonality. So I can just now you can just see here. Here you can see that Chicago, Paris, Tokyo. So in this case, what? Chicago is here, but not here. Boston both sides. Paris is here, but not here. Like the one which is, what is that? Not common. Okay, not common. Okay, so Paris, Chicago, then Mumbai is not there in only unique records are there. Okay, so those records there. Then zip is also similar to another function. Okay. Go here. Okay. This is zip. You can like zip, union, set difference also may be there. Okay. So now this is
in this function we get a list of tuples. It means we take one element from RDD1 and one element from RDD2. To get a tuple of data list.
Okay. So that is how you are using. Agar if you want to take out any distinct value, your distinct function is there. Distinct means like in RDBM use a distinct, remove duplicates automatically. So you can use a distinct also. Okay. So these are all what a few examples of RDD operations, which may be a transformation operation, which may be an action operation. Action operations are as a count. I'm giving only action operations are count and collect. Transformation operations are map, flat map, union, set difference, join. Okay, these are all considered to be a water transformation operations. Now, coming back to your word count problem, I said its word count problem is very easy here. Okay, so this is a okay. Now, word count problem, if I see, I think here, the first, I read a file. Okay, whatever that, if you remember, if you recall the algorithm which I explained, first it reads each element. Okay, each element, since I'm going to count a number of words, okay, it takes each word. Okay, distribute entire line into words. So you know that difference, how to make a word, how to differentiate two words, wherever you find space. Okay, for that, what you do that, we use a function called, okay, we use a function called what, space here. Okay, I read a first file. I read a file first. Then what I do, wherever space is there, okay, I use it. I print it. For example, let us take this example. One by one example, I'll make it only one line later. Now I have a file. I'll take the same file. Huh? What is that file name? I think I have tom.txt is also very big file is there. But I don't want to take it from a small file. I will take it. That's a purple cow. This file only I will take it. Okay. In this particular file, I want to count how many words are there, and you can replace with any file. Okay. The first, I want to see lines. Number of lines. Okay. So if I want to run this, okay, how many lines will be there here? 4 lines, correct? Sorry. Here, how many lines? Lines dot collect. How many? I think 4 lines. 4 lines are here, right? Now, what I do, I read each line. Okay, I read each line and split each word. Okay, how I'm going to split? I use a function called flat map. Flat map is also what it does. Map means what it does. It applies the function on every element. This also does same thing. Okay, this also what it applies function to every element of the previous RDD, but it prints line by line. Okay, that's the only difference. Now, if I apply this function here, see the output how it is. I'll attach here only. Okay, I use anyway lines I will use here only. 1 second, I'll execute. Run it. Now I'll just print this. Here you will find out each word. Here you can see how the output is. 1 by 1 it is there. Never, seen, a, purple, cow, I. Because wherever it finds a space, I'm going to split it. Now next line, what I do that? I want to convert this into a pair RDD. This is called a single RDD, where we have only one column with multiple rows. Because there is no 2 columns here. Only one column is never, seen, a, something like a single dimensional RDD. Now, if I want to make a 2-dimensional RDD, there should be one more element here. Okay. In that case, what I do in my previous word count problem, I attach 1. I attach what? 1 here also. What I do? I attach 1 here. Simply I attach 1 to every word I want to print. I will attach 1, just simple 1 value I will attach here. Okay, I'll use this. The output, this output I will send it to this particular function. Okay, then I'll run it and see here it will create a two-dimensional RDD. That's called a pair RDD. Like never, comma 1, seen, comma 1, R, A, comma 1, purple, comma 1. Every element I read it, I attach just one. I think this example although I have shown in word count problem. If you are absent, I'm sorry. Okay, so this example I have already shown with the Excel sheet map and all. Then now what I want to do, I want to count how many times 1, 1, 1, 1 word has appeared. I want to count. So here, when you have a pair RDD, okay, there are some functions in our operations of RDD which works like a map reduce. Okay, like a reduce by key, you are aggregating. Reduce by key means you are aggregating the data. By what? By, whenever you use a by means it works always on key column. You know already in map reduce, first column is always key column. Okay, so here we perform what? A reduce by. Okay, we perform a what? A reduce by here. Reduce by key. Key means the first whatever parameter is there, that's considered as a key column. In map reduce already you are aware. Mapper function takes two inputs, key and value, key and intermediate value it generates. So here when I'm reading two column RDD, first column is considered as a key. Based on that key, I will aggregate the data. I'll minimize the output. That's what we are using a reduce by key here. So here, when I use reduce by key, in this case, here I'll do it. Okay, I'm just reducing the output of whatever previous. Here anyway, two columns are there, word, whatever word is there, like never, seen, I, something, and I'm just attaching a 1. Each word I'll count. That's all. 1. How many times the word 1 is appeared? I will just simply count here. When I run this one and just print the value. So here when I print this value, now you can see here output is there, never, comma 2, cow, comma 1. Okay, it means that what happened, that I will tell you how it is before it reduce come to this part. Okay, I will explain, let me explain this. Run this and run this. Okay. This is my previous output. Okay, when this previous output is there here, go to a notepad. This is my previous output. Okay, now what is my function I'm using here? Reduce by. This is my function I'm using. When I'm using this function here, reduce by key. Reduce by key. Key means these are two columns. The first column is always key column. I have is a key column. Never is a key column. Seen is a key column. A is a key column. Okay, purple, cow, I is all new key column. Based on this key, based on first column, it will work. It will minimize the output. The first time A is there. Reduce by key lambda A comma B. Two variables are there. Equal to A plus B. What it does, this one will be assigned to A. Then it reads, okay, where I have is there. Anywhere else I have is there. No. Then B has a 0. Okay, B has a 0. So automatically, that's whatever value A equal to A, it prints A equal to 1. That's what is in A, I have is a 1. Now, let us take an example of never. Word 2 times, which one is appeared? Never. Never is appeared twice. It's appeared here. Okay, never appeared. First time when it becomes a never, So never one will be assigned to A. It starts searching. Okay. Seen, A, purple, cow, I, never. This one is also it finds second time. It assigns to B. When A plus B, 1 equal to 1 plus 1, sorry, A equal to 1, B equal to 1, A equal to A plus B. So that's become what? 2. So that A has a 2 value. Now it finds somewhere else never here. A is already having a 2. 2 equal to 2 plus 1. Okay. So that's what that time A value become a 3. So like this, how many times it finds that particular word, that many times it just summation internally. Okay. So in this case, if you use here simple okay. So here how many lines I'm using here? Hardly one line I'm using. Hardly one line I'm using to perform word count program. In MapReduce, at least 50-60 lines program I have written. But here we are making just one line code. Okay, one line code we are writing here. Just to find out a word count. You can give Mahabharata here. Within fraction of second, you will get this data. Because everything is in memory. But in MapReduce, you know that how much to work it. First mapper, 0%, then 10%, then 20%, 30%, 100% mapper होने के बाद reducer 0%, 10%, like this it goes. Because every time it has to interact with the disk here. Here no question of disk. Only one time it reads data from the disk, bring them to memory, do everything over there, write that. That's what in memory. Reading data from the memory is much faster than reading data from the disk. Okay, so this is what you can do in case of what MapReduce. I will give just 5 minutes. Can you do it? This same example. Do you have this code is there already, right? Purple curve is also there. Do it in front of me. I will just and let me know if you have an example. Now tomorrow bolo mujhe to problem. Every time it required a new mail. Okay. Already created mail again. They just created a different type. Once again you created here. Let us start with you. So for database.com page. Database.com. 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 Enter. Okay, you go here. Don't go over there. Now old communication. You one machine. You can. Check your mail. Start your file. Check your mail. Go. Select it. Go click on this. Get started. You are in passport password. Now enter your password. Your mail ID, your user ID, the password is yours. Create any name. Now it takes some time to create. Data अगर data है तो आप पर्पल का फाइल दिया ना वो इधर ले लो लोड किया तो वो फाइल्स कॉमा स्टोर में ना स्टोर कॉमा टेबल्स में You click on the data, click on create table, click on DBFS. No, upload the yeah. I see what you can start. No, the in party. I store part as right. No, don't do that. The database features, don't do that. No, I don't know this part. Next one. I was in here. Then you go to worksheet. Worksheet. Then click here. But before that, ensure that you're starting it. You're starting it, you start with the green. Okay, now you can run that. Because cluster should be there to run your query. You cluster create or run. What I take, go and take this. Create here. Go to the file, open this. No, you can't open it. You can't open. Directly go to workspace. Okay, when you are down, uploaded file. Yes. You want to upload, create tables. Go to DBFS. DBFS. Here. Check the file store. Table में I have to put this. Can now just upload. ये first name last name part companies part ये बात नहीं है just मैं command ये को part access go to workspace create first name no create no your option I have to join start writing command. I have path file read to read that video. Okay, minutes. It takes 2 minutes, depending on network speed and I don't know. 7 books. One way. Well, then we can get it on. But I mean, there we can take this part. Let's leave it around. Mail ID here. Let's go to the data. Now just change next select me and date प्रोजेक्ट भी कर सकते हैं वो आपका मशीन लर्निंग का प्रोजेक्ट भी कर सकते हैं वो पाइथन में किया है ना सेम कर सकते हैं तो ओनली डेटा कहाँ लोड करने वाले मेक इट एज अ सोर्स हम लोग डेटा पहले आर में कैसे कर रहे थे डेटा आपका हार्ड डिस्क में रख रहा था हार्ड डिस्क से वो पास दे रहा था और ये डेटा में जाकर अपलोड करो उधर लोड होता है डेटा वो डेटा तुम लोग सोर्स में पाइथन कमांड आर कमांड आर के अंदर ठीक है पहले क्रिएट क्लस्टर करो क्लस्टर क्रिएट करो तो वो तो कंप्यूट को पहले क्रिएट क्लस्टर चाहिए you have a cluster cluster machine को चाहिए लेना नहीं okay computer is not given anything you can do anything
sir it's currently running now green dot दिखा है
ready है ना green means ready run that command Front person. Control enter is a short enter. Plus control enter.
Sir, it's not able to previous files में देख सकते हैं read किया है previous files तो यहाँ पे हम previous files है इसको access नहीं कर सकते हैं notebook
फाइल से या नोटबुक है?
notebook है एक आठ files notebook है
एक्सेस नहीं कर सकता क्योंकि क्या वहां से कर पेस्ट करो वहां से you can use open that one डबल क्लिक नोटबुक सीधा डेटा में
हाँ सीधा notebook है
वो वन नोटबुक से अदर नोटबुक नहीं कर सकता
हाँ
ओके बट
लेकिन जो पहले का notebook है वो डायरेक्ट मैं एक्सेस नहीं कर सकता है वो पहले मैंने जुपिटर में बनाया था टोटल प्रोजेक्ट
हाँ वो उधर क्या करो आप लोग एक्सपोर्ट करो उधर आई पाइथन से कुछ फाइल है ना
हाँ
इधर वर्कस्पेस में जाओ फिर राइट राइट क्लिक
ये एक्सपोर्ट भी किया था मैंने
एक्सपोर्ट मतलब इंपोर्ट और इंपोर्ट करना पड़ेगा कौन सा फाइल
वही इंपोर्ट किया था कार वाइज वाला
नहीं वो खाली आ रहा है ना वो
उसमें है अच्छा वही वापस से
वो पाइथन का पाइथन ही तो आएगा ना इधर ये देखिए वो क्लास पे वेस्टर्न गेट बात कर रहे हैं ये वेस्टर्न गेट डेटा लोड की आई पाइथन से बना
हाँ
राइटिंग कर वो वाले से और डेटा देगा सर करने भेजा ना मतलब डेटा तो है वो रुपए है ना वो बंद करो अरे इवेंट एक अरे वो मिले नहीं हां तो उधर पाइथन में तो आएगा साला है तो आएगा वो जीमेल में जाके वो कैसे होते हैं वो कैसे करेंगे
मेरे को उसमें नहीं रहा पर मेरा इधर ही नहीं मेरा नहीं फॉरवर्ड कर दो
I think here, I think they have, if you go ahead now, implementing in Python, reduce by key, sort by key, है उधर सभी. Okay, इधर ये पूरा you can execute this statement how it is executed and all. RDD का ऑपरेशन मेरा सामने करो अभी तुम लोग. RDD में क्या क्या टीच किया ना ये मेरा सामने प्रैक्टिकल करो आप लोग. तो तुम घर में जाकर सोएगा. So tomorrow I will take a data frame directly. That's very important. Full data frame. ओके डेटा फ्रेम इजी है इससे इजी है क्योंकि ये बॉटम लेयर है ना उधर कॉलम पे आपको कॉलम पता चलता है और रीड करो बस इसके लिए चाहो एंड वन आई नीड फॉर मशीन लर्निंग तुम लोग ये यूज कर मशीन लर्निंग कैसा करेगा फंक्शनलिटीज आर देयर अगर if you want to save output ना, now you are seeing the output on screen. अगर आप output if you want to save ना, you can use save as a text file and give a path. Automatically you can save that file wherever you want. Give a file. Save as a text file. Done? Good. What about others? Done. So those are done. I think small examples are there in this case. PySpark transformation and action code. Okay, at home you can do it. Okay, there are so many things are here. I think everything is given. And just you do a cut paste. ऐसा नहीं है तुम लोग ये करने का. Just use and try to analyze that query. That's very important. See here, there are so many commands are around maybe 30-40 अलग-अलग operations का है. If you see in like map, filter कैसा करने का. Rest with a small data set it is there. Flat map, group by, okay, group by key, reduce by key, okay, map partition. So many things are here. So you can just small you can practice. So if you want to understand the meaning of this, okay, I think meaning is I have given you another file which as day one material is also there. I think source data, day one source. Which are the file I have saved with you? This. Okay, हो गया. I think python.zip. क्यों? देखो थोड़ा एरर क्या आ गए. हाँ, you cannot run. Only one you can run because only one node है ना इसमें. तुम लोग मशीन लर्निंग ग्लोबल कर सकते हैं या इजीली कर सकते हैं, सब कुछ कर सकते हैं, डीप लर्निंग भी कर सकते हैं, क्योंकि जीपीयू सपोर्टेड है. ठीक है, क्लासिफिकेशन इमेज क्लासिफिकेशन कर सकते हैं इसमें, तो फुकट में मिल रहा है ना आपको, कुछ भी नहीं. एक ही लाइफ टाइम एक्सेस रहेगा इसका. लाइफ टाइम नहीं, वो अगर वो फाइल कितना बार एग्जीक्यूट करता है, इट क्रिएट्स फाइल्स. 10,000 फाइल को ऊपर एक्सीड हो गया तो वो स्ट्रीमिंग एंड ऑल विल नॉट गेट एग्जीक्यूट. बट बाद में क्या है, दूसरा अकाउंट क्रिएट करो, ईमेल आईडी दूसरा क्रिएट करो, यहाँ से उधर एक्सपोर्ट करो. इजी है. हाँ, कल का क्या आप लोग डिसाइड किया? मुझको बोलो सकाळी संध्याकाळी वॉट एवर यू टेल मी. सो सकाळी आई मे टेक मैक्सिमम 1.5 आवर, नॉट मोर देन, क्योंकि कैसा होता है मेरा कल 2.5 घंटा रनिंग है. 2.5 घंटा रनिंग है तो आई हैव टू गेट अप, आई हैव टू स्टार्ट एट 6 o'clock 4 o'clock. 4 to 6:30 आई विल फिनिश माई रन. अगर आपका 7:30 है तो मैं 7:30 तक तैयार होता हूँ. 9 and 10, not 10, 9:30 max. 7:30 to max 9:30 और 8 to 9:30. 8 है तो 8 to 9:30 1 hour, 1.5 hour. मंडे कल मैं डाटा फ्रेम का मैं खत्म कर, आपका प्रैक्टिस के ऊपर है. मुझको क्या मैं आज भी खत्म कर सकता हूँ, 1 घंटा में फटाफट खत्म कर जा सकता हूँ, मेरा क्या प्रॉब्लम नहीं. सो अगर इफ यू आर कंफर्टेबल टू फिनिश लवकर, आई विल फिनिश लवकर. नहीं सर मुझको थोड़ा अंडरस्टैंडिंग होना चाहिए, क्या आना चाहिए तो. और मुझको मैक्सिमम मंडे चाहिए. देखो 4 घंटा 8 घंटा, कल 4 परसों 4. कल मैं 3 बजे को 3 to 4. अभी आज है तो 2 घंटा करो, एक्स्ट्रा है तो ब्रेक कर 2 घंटा करेंगे, नहीं तो कल. और कल हम थोड़ा कम कर सकते हैं.
मंडे का थोड़ा टाइम एक्सटेंड कर दें.
मंडे फिर मेरा चेक करना पड़ेगा, मैं ट्रेन कहाँ है, मतलब भागना पड़ेगा मैं.
सर आप
सी देखो ऐसा है, मैं मंडे मेरा 3:30 को ट्रेन है लगता है. आई हैव टू चेक इट. सो अराउंड 12 तक मैं ले सकता हूँ मंडे, क्योंकि मंडे मेरा एक्सरसाइज रेस्ट है. मैं कभी भी सुबह आ सकता हूँ, कभी भी सुबह आराम से आ सकता हूँ, क्योंकि मेरा कुछ नहीं काम, एक्सरसाइज नहीं. सो उठने का, ब्रश करने का, स्नान करने का, आने का, ऐसा इतना. तो रेगुलरली मैं 5, 6, 4, 4:30 को उठता हूँ. मंडे या संडे कुछ मैं आ सकता हूँ. दैट्स पॉइंट नंबर 1. मंडे का 4 घंटा ले सकता हूँ. अगर कुछ रह गया, आपको कुछ ब्रीफिंग चाहिए तो अगले मंडे मैं छुट्टी पे घर में है, लेकिन उस दिन मैं थोड़ा आई कैन स्पेंड विथ यू पीपल ऑनलाइन और ऑफलाइन, वट एवर इट इज इफ यू वांट. वो अगर ब्रशअप कुछ टोटली आप ब्रशअप करना चाहता है तो इट्स नॉट माई थिंग्स, क्योंकि टोटली मुझको अलॉट किया था 36 आवर्स. कितना साल, कितना घंटा हो गया अभी अप्रोक्सीमेटली, ये मंथ कितना हो गया हमारा? हाँ, ओवरऑल और ये एक पकड़ करता हो गए क्या? इंक्लूडिंग लिनक्स का छोड़ पर. एनी हाउ आई डोंट, टू मी मुझे इतना प्रॉब्लम नहीं, क्योंकि मुझको कल परसों तक मेरा काम खत्म करता हूँ. अगर परसों आपको चाहिए तो आई कैन, अदरवाइज यू कंटिन्यू योर्स, आई विल गिव ऑल दोस थिंग्स, यू कंटिन्यू. अगर कुछ प्रॉब्लम है तो यू कैन कॉल मी, आई विल हेल्प यू. अच्छा, अभी क्या करने वाला है? तुम लोग बोलो ना, मुझको कितना है उतना कल कर नहीं, मैं फ्री है, मेरा कुछ काम नहीं, घर में भी जाकर मेरा आई डोंट हैव एनी. हाँ मंडे दे सकता हूँ ना मैं मंडे आई विल जस्ट चेक माय सेशन माय ट्रेन अकॉर्डिंगली आई विल टेक इट मंडे में दे सकता हूँ मैं मंडे छुट्टी पे मैं सुबह दे सकता हूँ कभी भी
10-15 मिनट का ब्रेक लेते हैं फिर 2 घंटे करते हैं 5 PM करके
हाँ
नंतर नेक्स्ट फ्राइडे
लेकिन वो मैं उनको बोलो क्या है वो
आपको उनको भी नहीं करना पड़ेगा
नहीं करना पड़ेगा
शेड्यूल काम होगा वाला तो कल के एक्सटेंडेड ले लेता हूँ
नहीं बट ऐसा नहीं आप लोग को प्रेशर नहीं होना चाहिए ना आई डोंट वांट दैट व्हाट आई डोंट नहीं आप लोग देखो मुझको क्या प्रॉब्लम नहीं आज 1.5 घंटा करेंगे नहीं तो कल 2.5 घंटा करेंगे आप लोग देखो मुझको आज नहीं तो आज नहीं तो कल तक मुझको
फिर
अच्छा ठीक है अभी आप लोग क्या करो अगर if you want to save that output wherever you want to save this output okay what you can do here simply what you can do that here I think the output you divert into disk okay that's a save as is a command which you can use example if I say here okay this is my output till here I know that here I can collect कर सकता है okay I can use a collect statement now simply use a save as a text file save as a text file and give a path okay in that path your output whatever the output you can see here that output will be stored into that disk save as text file and give a path name and you whatever name of your output file my output or output result something you can give so once you for example like I say here I'll show you first here okay what I did the output I at the end save as text file I run this okay when I run this okay it will get output is sent to a disk so how to see that output go to data here okay in the data go to dbf create table dbfs in the file store in the file store tables okay my output one you can see my output one is a folder get created everything is mapped to a folder output in that output is output agar if you want to write into a disk just save as I think आपको इसमें है देखो save only thing is that you should have that properly this one save is save, A capital letter, text capital T capital letter, F capital letter. Save as.
Save as text file.
No, it should define as save as a text file into bracket path. हाँ वो बाद में ना continuity ना output is a continuity. Only one command. I send that. Now, okay. Now I have shared with you some files right here. Just take it and you can, if you want to continue, otherwise you can close, not a problem. So I have given you one file right here, one more file. In the text file, did I share this one python.zip? Check all of you. Python.zip is there or not? This is very important for tomorrow and day after tomorrow. Just check it. Okay, python.zip file. There are three files are there here. One is a python.zip, python 16.12.2022.dbc, python 12.11.2022.dbc something. मिला क्या आपको? नहीं, उनको भेजो पट से. भेजा, डाउनलोड कर आपका डेस्कटॉप में रखो वो फाइल. ओके, एंड अनजिप करो. Let me know once you put on your desktop and unzip it. दूसरा लेक्चर कब है ना? आपका नेक्स्ट सेशन कौन सा है? कब है वो? Done? Okay, now you go to here. Go to here. In this case, wherever that your here is there, that here workspace. Gone? Have you gone here workspace? Okay, what is the file name you have downloaded? तो जिप अनजिप करने के बाद क्या आ गया? अनजिप करो. अनजिप में क्या है बोलो? हाँ, नहीं, दूसरा पाइथन डॉट 12 डॉट समथिंग है ना, वो 12 और 16 कौन सा भी है? हाँ, पाइथन 16 है ना, पाइथन 16 वो अनजिप करो. अनजिप करने के बाद क्या आ गया आपका? नहीं रे, हाँ अलग है ना, वो डोंट ओपन इट, यू एक्सट्रैक्ट इट. अच्छा डायरेक्टली है क्या? एक्सटेंशन क्या है उसका? DBC ना? हाँ. So what you do that, right click here. Okay, on workspace. Okay, on all of you, DBC file है ना? Okay, on workspace, right click. Right click करने का import. Go to import. Click on import. When you click on import, it comes to a drop of file or upload. Okay, then click on browse. Okay, take that file, DBC file. Go to the DBC file and import it. हाँ? Import करो फाइल को. हाँ, whatever it is, import करो. उसमें आपका पूरा तुम्हारा कुंडली है उधर. है क्या? हाँ, इंपोर्ट किया. ओके, आपको क्या आ गया इंपोर्ट करने के बाद इधर? हाँ, इंपोर्ट होने के बाद मुझको बोलो. आई थिंक यू विल गेट लाइक दिस स्पार्क समथिंग. यू शुड गेट दिस स्पार्क ILT या कुछ होना चाहिए आपको वैसा. ऐसा स्पार्क ILT 3.0.2 कुछ आना चाहिए. एक फोल्डर इंपोर्ट होना चाहिए उसमें. हाँ, ठीक है. So go to agenda. Double click on agenda. 105. So that is your total training material, including code, including solutions. Okay, we go to programming. कौन सा? Agenda 105. Okay, एक प्रोग्रामिंग है 3 दिन का. तो 3 दिन प्रोग्राम हम कितना दिन में कर रहे हैं? वेरी बेसिक पे हम 8 घंटा में कर रहे हैं. हाँ हाँ, फर्स्ट में जाओ. तो एजेंडा में जाना है. हाँ एजेंडा में. हाँ, उसमें नॉर्मली करता है 3 दिन प्रोग्राम. 3 दिन प्रोग्राम टोटल स्पार्क 100% एक्सपर्ट इन स्पार्क वो लोग. हाँ राइट. ये आप फर्स्ट किया तो आप लोग स्पार्क ओवरव्यू हो गया. स्पार्क ओवरव्यू आप अगर है तो आप पढ़ो आप लोग. ओके, बाद में मैं कल वो है ना बिल्डिंग डेटा फ्रॉम CSV, बिल्डिंग डेटा फॉर परक्विट, quickly I will go through. Quickly few operations I will go through tomorrow. And tomorrow अगर चाहिए तो अभी आज नहीं tomorrow. These things I will go through and later we can do practice on this. Let's start with the data frame. So उसमें आपका मशीन लर्निंग का भी है. एक ML का देखो लास्ट को है लास्ट सेशन. और इस स्पार्क स्ट्रीमिंग का भी है. स्ट्रीमिंग इज नॉट पार्ट ऑफ योर कोर्स. तो आपका ML का है ना लास्ट को छोटा ML पाइपलाइन कुछ है ना. ML लर्निंग पाइपलाइन. हाँ, तो उसमें क्लिक किया ना बहुत सारे लीनियर रिग्रेशन भी है, सब कुछ है उधर. के क्लस्टरिंग सब कुछ. ओके, वो उसमें आप दिस इज एक्चुअली वी रन फॉर 3 days प्रोग्राम. ओके, अगर इधर आ गया समझो ये है. ओके, 105 ना आपका. 105 में ये आपका करेक्ट है. सो इसमें दिस टॉक्स अबाउट व्हाट इज स्पार्क एंड ऑल. ओके, स्पार्क में ये क्या है? हु इज क्रिएटर ऑफ स्पार्क एंड ऑल. वेयर इज दिस? When you click on this night, this talks about we cover. These are all very expert people. Okay, we cover like Apache Spark overview. What is Apache Spark? What is RDD? Okay, this is a theory part and your architecture of Spark. Okay, Scala, Python, Java, and all. Okay, then quick jobs and all those things. Then here normally we start with data frame normally. Okay, data frame मैं कल बताता हूँ आपको, so that we can use. आपका machine learning is here. Okay, आपका इतना पूरा है ना आपका machine learning, आपका machine learning 105 में गया तो, so this tomorrow I will fully cover on data frame, how to read data from CSV file, how to read data from perquit file, how to read data from text file. Okay, वो जब उधर data frame में आने के बाद we can do all operations again, like how to filter data, how to drop column, how to आपको pre-processing करता है ना आपका. So this is all part of for that data frame operations are there, like filter, drop column, distinct, join, aggregate, सब कुछ है बहुत सारे. वो होने के बाद then we will go through the this one machine learning part here. Okay, वो परसों machine learning में क्या क्या आपका ये है, how to create a machine learning pipeline using some data set. इधर नहीं यार, आप लोग को आ रहा है क्या? देखो आप लोग आ रहा है क्या उधर आपको? आ रहे हैं ना? ठीक है, नो प्रॉब्लम. आपका सो इधर, हाँ इधर लेट मी जस्ट चेक. Not open with the URL. ठीक है, मैं घर में चेक करता हूँ उससे क्यों नहीं आ रहा है. तो मशीन लर्निंग का है ना, बहुत सारे मशीन लर्निंग ये है एक्सरसाइज आर देयर. सो आई विल गिव ओनली वन एक्सरसाइज टू यू. रिमेनिंग तुम लोग अब क्या क्या लर्न किया ना मशीन लर्निंग में, बहुत सारे लर्न की, के मींस लर्न किया, क्लस्टरिंग लर्न हो रहा है. आप लोग प्रैक्टिस कर सकते हो, रेडीमेड प्रोग्राम्स है, जस्ट यू रनिंग कर जाने का बस. So I will tell you tomorrow where from you read the data and how the architecture is, and you will just work on that all ready-made part. So आप लोग I will explain, you can do it immediately practical. So code with code, solution, exercise, everything is there. That notebook पे. अगर आपको Scala चाहिए तो Scala, SQL है तो SQL, Python है तो I am giving you only a part of Python part. Okay. क्या करने, हाँ कल का मुझको बोलिए. कल यू डिस्कस अमॉन्ग योरसेल्फ एंड लेट मी नो. मॉर्निंग एक है मेरा ऑप्शन 7:30 to 9:30 मैक्स, और एक है 7:30 to 9. अगर 7:30 का है तो यू शुड concretely tell me, otherwise 8 o'clock is also okay, 8 to 9:30 is also okay, but maximum 9:30, not more than that. That's one part. Second, हाँ sir. Anyone is there from this side? Huh? Suresh Kumbar.
Yes, sir. Yes.
Yeah, I think please. Yeah, I hope you have created Databricks platform, na?
Yes, sir. Yes.
Yeah, I think Prathamesh will share. I think Python file, na? You.
Yeah. Yes, sir. Received. Yes. Yes.
Okay, great. So just you go through that one whenever you find a time. So
Okay,
tomorrow just we'll discuss that. Tomorrow I have some marriage, so I wanted to complete some part in the morning, some part in the afternoon, or one stretch in the afternoon. That's what they are discussing now. We'll let
Yes,
you know.
sir. Yes, sir.
Okay. I hope you are all understanding, right?
Yes, sir.
Okay. Yeah. Great. सकाळी ऑनलाइन इज बेस्ट फिगर इफ यू आर टेकिंग, क्योंकि वो 1 घंटे के लिए आई कैन नॉट कम. देयर इज नो पॉइंट आल्सो कमिंग. Okay, I'll stop sharing. So, Sresh. अभी भी 3 बजे को भी चालू होता है ना क्लास? No, some people start when last time people came and we went outside from there. I prefer only this. Weekdays नहीं होता. नहीं वो लोग वैसा है, उत्कर्ष के साथ बात करना पड़ेगा ना. She will send a meeting request and all. हो सकता है, मुझको क्या है 3 to 7 आता है. तुम लोग, मुझको क्या प्रॉब्लम है?
सुबह कितने आवर्स का बोल रहा था?
सुबह मैं 8 to 9:30 1.5 घंटा ले सकता है ऑनलाइन. ओके, शाम को चाहिए तो अगर मैं शादी को आने के वक्त मैं मेरा बैग लेकर आता हूँ, आकर डायरेक्टली यहाँ से इधर आ सकता है. अगर जल्दी गया तो 1 बजे को मेरा खत्म हो गया, मैं डायरेक्टली घर को जाकर मेरा स्कूटी लेकर आता. नहीं, कुछ रह गया, ये आ गया, आप लोग चाय पीने को आधा घंटा से 1 घंटा ऐसा होता है ना. आई शुड नॉट हैपन दैट. 8 to 9:30, then we can take it.
8 to 9:30. Okay, sir.
8 to 9:30. हाँ, tomorrow 8 to 9:30. बाद में शाम को 3 PM आना पड़ेगा, क्योंकि वो तो नेबर के शायद 11 बजे को 3 बजे तक हमारा काम क्या होगा, अक्षता डालकर खाने का आने का हमारा क्या है. 3 to 6 morning.
8:30 to 9:30.
8 to 9:30. हाँ, 8 to 9:30 online.
Yes, sir.
Okay. Anyway, now you are all ready-made. आपका पास है ना? Only I have to execute and explain. That's all. You people also start executing here. Okay, okay, Sresh. Morning, they are discussing between 8 and 9:30 one session, and afternoon 3 to 6.
Yes, sir.
Okay, yeah. Thank you. क्योंकि 1-1 घंटा के लिए आने का मतलब नहीं.